Сергей, там Стефана, он говорит, что он в ожидании находится, вы должны принять.
У него как имя? Я имя не понимаю.
Ну, Стефана ушла на латинице.
Сейчас, минутку. Да, 2 минуты. Угу.
Lilia?
Sì.
Ho appena parlato con Paolo.
Sì.
Dice che è in un meeting e arriva fra 45 minuti.
Ah, va bene.
Aveva un meeting con i suoi amici degli Loud, per cui fra 45 minuti al massimo arriva, si connette, ok?
Ok, grazie, Tiziano. Hassan, hello, good morning.
Good morning. Good morning to you.
Welcome.
How are you?
Fine, thank you. And you?
Good, thanks. Thank you.
Thank you to you for joining us.
Pleasure. Anytime.
Лилия Ильдусовна, еще раз, мы не видим его.
Он сейчас попробует снова зайти, а Пауло присоединится только минут через 45-50. У него сейчас другая встреча.
Хорошо.
Приняли, да, его?
Сейчас вот смотрим. Не вижу пока.
Сейчас я попробую позвонить.
Так, все, подключился, Лилия Ильдусовна? Подключается.
Окей. Окей. Sì, l'ho rimandato già, girato.
Так, ну докладчики тогда у нас вроде бы все подключились. Тогда, да. Евгений Анатольевич, начинаем? Евгений Анатольевич, тогда я всех запускаю, да?
Good morning, Lilia.
Hello?
Так, сейчас, минуточку, попрошу всех выключить тогда микрофон, и я всех запускаю.
Dear participants, could you please switch off your microphones to let everybody join our chat? Thank you.
Все, можно начинать.
Good morning, dear participants, dear friends, dear colleagues. I am Evgeny Vdovin, Vice Rector for Research Work at Kazan State University of Architecture and Engineering. I am glad to welcome you at the second International Scientific Conference on Socio-Technical Construction and Civil Engineering. Today we continue the conference with plenary session. I wish you all successful, productive work. I give the floor to the conference moderator, my colleague, PhD, Associate Professor, Head of Department of Foreign Language, Mary Gulkanyan. Thank you.
Good morning, dear participants, dear colleagues, dear friends. Today, as Evgeny Anatolyevich said, we continue our conference, and first and foremost, we would like to give the floor with welcome words to our rector, Professor, PhD Rashid Nizamov. Please, Rashid Kurbangadevich, you're welcome.
Yes, good morning. My name is Rashid. A lot of you know me, and I'm rector of Kazan State University of Architecture and Engineering. Kazan is the capital of the Republic of Tatarstan.
Я вообще ничего не понимаю, все на английском.
And I think we should win pandemic, and you should come to Kazan. You should visit our university, and it will be a great trip, I promise you. And secondly, today we are opening our scientific conference, second international conference, Socio-Technical Construction and Civil Engineering. Organizers of this conference, it's our university, our friends from St. Petersburg, Polytechnic University, it's our friends from East London University, and our young scientists, our organization of Republic of Tatarstan, and Moscow Automobile and Road State Technical University. In our conference, taking apart a lot of scientists from different countries, and it's important for us. And from Greece, Great Britain, Germany, USA, China, Japan, Kazakhstan, Vietnam, and others. Especially, I have to say, good words to my Vice Rector Evgeny Vdovin, who organized this conference. It wasn't easy, but he did it. I'm very happy to see here my and our old friends from, for example, Mark Sedgel, Peter Lakin, Nikolai Vatin, Stefano Bertocci, Alfides Perepes, Hassan Abdullah. Hello guys, I'm very happy to meet with you. Scientific work is a successful direction of our activities, and one of the most important reasons is our modern scientific educational centers. And right now I'm going to greet my colleagues from these centers, and first range. I have to say we developed many construction schemes for industrial and civil engineering, and you know, in 2018 was football championship in Russia, and we constructed in Mordovia, Saransk, Mordovia Arena, it's in Saransk. We increased of number of places for audience. It wasn't easy because the stadium was ready in this moment. It's example. And the next place, hello guys, Isayev, Gibranov, who are.
Yes. Hello. We're very.
Hello us. Thank you guys. Next, Buffett Place is place for architects, young architects, and it's a famous place, and I think we work successfully here, and we won a lot of international competitions for young architects and students. For example, our students, Ayrat and Ruslan, won special competition in New York, and Forbes wrote about it. Today, about 20 our students work directly.
Dear participants, we're having like little technical problems. We're fixing it. Okay, give us a second. We'll let Rector in and we continue our conference. Okay, we're waiting for a better connection. Let's say hello to our Buffett Space Center. How are you there? Is everything okay?
Yes, very confident. We want to say hello to Professor Imamov, but we're waiting for him to get back to us.
Okay. Thank you very much. Have a productive day. Thank you, colleagues. Okay, and maybe we may go back to our strength, our center, research center strength. How is it going there? Ready? How are you there, guys? Strength, прочность. Hello, hello, everybody.
Yes, so yes. Hello?
Hi. Is everything okay?
Let's say the word, yes. We're very ready to listen for this conference, and we wish you luck and to create more good questions.
Great. Thank you. Thank you very much. And I would like to remind you that we will have chat. And if you have any questions, you may say it yourself. You may ask your questions yourself, or you may send the question in our chat box. We will read it and we will answer it. Okay? We read, we answer. Okay, let me do this one. So. Okay, maybe we may continue with the next center, that's urban planning for architects and designers and urban planning. How are you there? Is everything okay?
Good morning, dear participants, dear guests of our conference. We are happy to greet you all in our Research and Scientific Center, Urban Planning.
Hello.
Thank you very much. Thank you very much for such a brilliant conference.
Thank you. Great. So, next center is roads. Roads, how are you there? How is it going? Hello. Hi. I can see myself in your screen. Great. So, okay, great. Next center is systems, engineering systems. How are you there, guys?
Good afternoon, participants and guests of our conference. We are happy to greet you all from our Research and Scientific Center Systems. Hello.
Hello, 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 everybody. And now the last but not the least, which is very important, center technology. Technology, how are you there? Colleagues, hi.
We're fine. We're happy to greet you from here.
How is it going?
You don't see it's fine. I don't know why you don't see us, because we see you.
Oh my God.
We're fine. We're waiting for the speech of our rector.
Okay, just give us a second.
Full of enthusiasm.
Yeah, okay.
Okay.
Okay, and I think we're ready to give the floor again to rector in a few seconds. So maybe we can do a little flash mob, something like you may all wave and we will take a picture of that. Okay, can you please switch off your microphones and switch on your cameras and wave, like to show how happy you are. Hello, just Tatiana, can you take a picture? We have a big screen on the wall. So hi guys. Great, great. Unfortunately, we don't have music. It's kind of scientific conference. So okay. Now we're waiting for to fix the technical problems, but we're ready to give the floor to our next honored guest, Andrei Keller, rector of Moscow University. Can we see you, Professor Keller? You here?
Коллеги, добрый день.
Hello. Good afternoon,
hello,
dear
colleagues.
От лица Московского автомобильно-дорожного государственного технического университета я приветствую участников конференции.
We greet all of the conference members and participants from the Moscow Automobile and Road Construction State University.
Московский автомобильно-дорожный университет является одним из ведущих университетов Российской Федерации в области строительства автомобильных дорог.
Moscow Automobile and Road Construction State University is one of the leading universities in Russian Federation in the area of road construction.
Мостов, тоннелей, уникальных сооружений.
Also of the bridges, tunnels, and other unique architectural constructions.
И других объектов транспортной инфраструктуры.
And other objects of the transport infrastructure.
В последние десятилетия мы наблюдаем кардинальную смену парадигм в области строительства, проектирования, изыскания и содержания элементов транспортной инфраструктуры.
In last decades, we have seen a radical paradigm shift in the sphere of the modeling, construction schemes of the roads and the different constructions.
Это связано в первую очередь с бурным внедрением цифровых технологий на всех этапах жизненного цикла объектов дорожного строительства, аэродромной техники, мостов, тоннелей и других элементов магистральной инфраструктуры, которая внедряется на всех территориях развитых стран мира.
It's connected to the rapid introduction of the digital technologies at all cycles of the construction of airfields, roads, and so on. in all objects and subjects of the road infrastructure.
В этой связи я не сомневаюсь, что сегодняшняя конференция позволит ученым разных стран, разных научно-образовательных центров обменяться сложившимися практиками проектирования, изыскания, строительства и эксплуатации дорог и других объектов магистральной инфраструктуры.
I'm totally convinced that today's conference allow construction of the road objects, infrastructure road objects.
Желаю участникам конференции хороших дискуссий, новых знакомств, обмена опытом, обмена мнениями и, безусловно, выработки новых консолидированных подходов к решению актуальных задач, связанных с развитием дорожной сети как Российской Федерации, так и всего мира.
I wish an effective work for all of the members of the conference in all of the spheres connected to the development of the network and also to exchange their own experience and in different actual fields of the researchers.
Удачи вам, уважаемые коллеги.
Dear colleagues, I wish you luck.
Спасибо.
Thank you very much, Professor Kender Andrei Vladimirovich. Thank you very much for such warm greetings. And now, as I know, we're ready to go back to the speech of our rector, to the welcoming speech of our rector, Rashid Kurbangalevich. We're ready.
It was Buffett Place, yeah?
Yeah.
I talk about Buffett Place, about this magic, unbelievable place for architects. And I told we prepare high-level architects, and our students won a lot of international competitions. And for example, I told about Ayrat and Ruslan, these guys won competition in New York, and Forbes magazine wrote about it. And it's not only with successful work in this area. And next, I have to tell about our systems. Again, Buffett, guys from Buffett, hello. Rezida, Ilnar, students, are you?
Hello, good morning.
Are you happy to see me?
Yes.
Yeah, that's great. I'm happy too. And okay. And next, our scientific center is systems, and we worked successfully here too. And for example, my colleague Ziganshin Arslan made research and new ventilation systems, and he sold it to business, and I think he will be rich in future, I hope. Next direction, technology. It's materials and sorry, I forgot about guys from systems. And hello everybody, are you?
Good afternoon, Professor Nizamov, dear participants and guests of our conference. We are happy to greet you all from our Research and Scientific Center Systems.
That's great. Hello guys, we are happy too. Goodbye. Next, technology. It's new technology and materials, and we have our republic, our region have problem, lack of cement, steel, and firm course aggregate production, and we help to our republic to solve this problem, and it's successful business. And today, I think my colleagues from this center, Professor Hosen, first of all, and his colleagues, I think, are ready to greet us. Hello, guys. Are you here?
Hello, dear colleagues, dear guests and participants of the conference. Hello, dear Professor Nizamov. We are happy to greet you from our Research and Scientific Center Technology.
Okay, goodbye, guys. Next roads, it's, I think, Evgeny Vdovin. It's his great work in this area. His a lot of money, a lot of different modern solutions, and I think we work successfully, especially in this area. We offer different solutions. For example, in Tatarstan, bitumen have poor quality, and we offer, for example, special polymeric modifiers. We offer special road construction to the villages, and I think you have to speak with my colleagues, and they can tell you a lot of interesting things in this area. And my colleagues, are you ready to greet me and participants of this great conference?
Yeah, we are surely very grateful to see you, and we welcome you in our research center roads. Hello.
Hello, but you told it without happiness. It's great day today. Hello, guys.
Hello.
Okay. Next, urban planning. It's our new place, and today chief of this place, Professor Dembic. I think he and his colleague are ready to greet us.
Good morning, Professor, some of the participants and guests of our conference. Let me one more time greet you all from our Research and Scientific Center Urban Planning. Hello.
Thanks, and I know, for example, today you work successfully and you make urban planning for Nabережные Челны. It's a big city in Russia, and a lot of you, I think, know about KAMAZ cars. It's with factory in Nabережные Челны, and I think it's you have to visit us and to see this center too. And next, our magic, our special, our visual project, it's Dashka. It's place for young architects. 1,500 girls and guys visited with school, and it's give us good mood, happiness. What we are hope with guys will be our students in future, and I think it's unicum project in Russia, maybe not only in Russia. Okay, and sorry, and Dashka, are you here? Hello, guys. Hello.
I'm sorry, Dashka has classes, so they are.
No problem. Next, I think it's not finished. And today we are going in this year open new centers. For example, here you can see our center heritage. This place will be ready, I think, in November, and for reconstruction for our old city. Our old cities, it's important place, and we should teach our students how to work in this direction, in the right direction. Okay. Next, it's digital. You know, today is a modern trend, and for example, my colleague from England, Peter Latin, give us knowledge about his experience in England, and it help us to organize this new center, and it will be ready in July, and it will be for BIM technology to in construction industry, and I hope it will be ready. And next, archiphysics. It's for new place for students and scientists, and it's a new center. I think it will be the best in Russia too, and we hope, and we are going to open with center in the summer, and today we work successfully, and I hope it will be this center will be ready too. Okay, next it's a new place for architects, theory and practice, and I think I hope I know Айдарова, Новиков, Денисенко, and your friend and our colleagues of this department help us to organize this center, and this center will be ready, I think, in the winter, and I hope. Next, Agash wood. It's will be special place for students, architects, scientists. We going to work suspect. We're going to connect with business. We're going to in Kazan a lot of wooden houses, and we have to know how to work with wood in right direction, and it's and the most important, a lot of guys from Dashka are going, we think will work in this area too. That's why I think it will be unicum project in Russia, and 1.5 years, and this center will be ready, I promise you. And if you visit us, you can see these centers, okay? And I think it's end. I hope this conference will be useful, will be give us opportunity to change experience, to discuss different things, and everybody can tell about new decisions. But most important for me, I hope next year you should come to Kazan, and we have to be here. We have to want to be in pandemic, and everybody should come to Kazan, and I promise you it will be a great time, unbelievable time for you, for me, for everybody. Goodbye.
Thank you very much, Professor Nizamov. That was a nice speech, and we're sure that we're going to have a nice and wonderful conference. And the next, we would like to give the floor with greeting to our guest, Principal Fellow of the Higher Education Academy, Fellow of the Royal Society of Arts, Professor Hasan Abdullah. Hello, can you hear us?
Yes, hello.
Yes, you're welcome.
Can Can you see my slides?
Yeah, it's all fine.
Excellent. Right. Greetings from London, colleagues, and thank you so much indeed, Professor Rashid, for the very, very inspiring plan and introduction. I'm really so impressed. I'm so amazed with your great vision. We are very, very honored to have the collaboration with Kazan State University for Architecture and Engineering for a number of years. We are indeed so proud of that collaboration indeed, which is going from strength to strength. I'm very, very delighted to join this very prestigious conference on socio-technical construction and civil engineering. In fact, this conference addresses a number of highly interesting areas, such as tunneling, bridges, building constructions, energy, building performance, sustainable development, just to name a few. And I'm very, very confident that you had a very, very stimulating and informative discussion throughout the various sessions over the last few days. These great topics you had discussed and addressed have major impact on our lives, socially, economically, and environmentally. And the overall conference recommendations, I'm confident it will be of great interest to experts, researchers, policymakers, and that would influence basically the way these areas are progressing moving forward. If you allow me, I would like to take this opportunity to share with you some headlines of some of the projects we are currently working on jointly with various organizations and companies. But before doing that, very briefly, University of East London is a very, very distinctive university, extraordinary in terms of we have students from over 135 countries. Our vision is to transform lives and society with great focus on careers for the fourth industrial revolution. So you can see here our location, which is quite unique. We are based in East London, and as you all know, London is shifting east, center of the globe, and our area is basically the most urban regenerated area in maybe Europe. And we are fortunate to be surrounded by major industry. We have next door to us the financial city. We have major companies, and we collaborate with London City Airport, with major construction companies such as Skanska, Costain, and so on. And these obviously generate great opportunities for staff and equally students. And in terms of offering them real life projects, real life experience to prepare them for the jobs of the future. And as a result of that, we have been shortlisted by the Times Higher for Outstanding Entrepreneurship University for the year 2020. And that's something we are also continue strengthening across our university. You can see here we have very, very fascinating campus, hopefully comparable to what Professor Rashid was presenting, very exciting, iconic sites he was sharing with us. We also have, as you can see here, waterfront, fascinating campus, innovation hubs as well, which basically generate all the great ideas industry is looking into. And that stimulate that sort of creative and innovative thinking for students, staff, and our key stakeholders in industry. The university.
Вещает на своем языке, нам что? Мы сейчас у нас выходные.
So the university has a major history back to 1898 and is being developed and evolved, and we offer similar to Kazan State University for architecture and engineering, flagship areas in architecture, civil engineering, cutting-edge research in artificial intelligence, smart city, cybersecurity, across various health, business, law, and so on. We actually transform lives, and by focusing on this sort of flagship area, and we work also with major professional bodies. We work very closely with industry, and you can see here a snapshot of some of the facilities and real life projects our staff and students are focusing on. In order for us to be a global international university, we have obviously to ensure that the quality and the standard of our offerings are fully accredited by major professional bodies. So you can see here just a snapshot of those professional bodies we are working closely with. We have over 120 professionally accredited programs across the institution. We also offer very bespoke sort of courses to industry. That's what you call it, apprenticeship, where students spend 20% of their time on campus at the university and 80% in industry. So we do this with major companies such as Accenture, Barclays, Skanska, Canary Wharf, and so on. Here is again, because I was jealous of what Professor Rashid was presenting, the fascinating labs and so on. Here as well, we have London Center for Digital Design and Fabrication, because our aim is to digitize and automate the construction sector in order to ensure that it's very efficient, very productive, and obviously adapting to the state-of-the-art technology in 3D printing, in robotics, in stereolithography, and so on. And these are just examples of some of the work our students and staff have been generating. Our ethos is basically applying theory into practice. And this is, again, example of our students working on real life projects. So we are here simulating, students simulating in a major project, the Gherkin in London. So doing the modeling of that and doing the actual construction in the field itself. And that's really very fascinating because it gives the students this sort of real experience in working with not just the design, but the material and facing the challenges when they obviously do the construction process. So this is, as you can see, quite amazing. Our students as well being involved in addressing some of the major societal problems. So we have, for instance, on both sides of the Thames and the Docklands, how will you be able to connect the flow between both sides? And this is one of the bridges our students designed in partnership with Atkins. Atkins, as you know, is a major construction consultancy company. But you can see here the beauty of the modeling, the beauty of the analysis the students obviously have been presenting here. I would like to touch base very briefly with you on some of the major projects are taking place nationally in across the UK. Because there is about over 400 billion investment up to 2025. This investment, the government is focused on transport, and there are a couple of projects I will touch base on, which is Crossrail and HS2, High Speed 2, on science and research, on communication, on water and sewage, on energy, and so on. So these are major projects, but it would be nice to learn from some of these great projects in order to basically add value and bring more prosperity to the economy. And the first project I would like to touch base on is Crossrail. Crossrail is a national project. This project is over 18 billion pounds. The project is almost about to be completed. Is basically about, is a project aims to connect East London to West London, connecting the east to the west of London. It's about 103 kilometers, and 31 kilometers is basically going through tunneling underneath the financial city, underneath London, which is obviously a major challenge to achieve in this case. But you can see here, these sort of projects will cut travel time from 1.5 hours to almost about 40 to 45 minutes. And here is an example of the progress of the project which have been taking place. And our students and staff have been participating on that. So you can see over there to the top to the right is the station in Canary Wharf. Very statically impressive design, but also it acts as a gallery, if you like, for passengers, users, and so on. So it's a great thing, obviously, to see there. Here is one of our actually graduates who actually a project manager in that project for that Canary Wharf station. And that's where the connection with industry is mission critical in this case. The second project I'd like to touch base on is High Speed 2. This is, again, another major national project. And this project is basically aims to connect London to Birmingham, to Leeds, all the way to Manchester. And that's, again, to basically offer a more pleasant and in a short time travel to passengers. And this is just a snapshot of what really these sort of stations would look like, because it's, again, is about incorporating business activities as well. Is about offering an entertainment, a sightseeing, if you like, while you are traveling in this case. So it's quite fascinating from the design point of view. The third project I'd like to touch on is about London City Airport. And we're working with London City Airport because London City Airport is expanding the airport in order to allow to cargo to travel all the way to the Far East because of the business growth in around East London in this case. And how East London as an airport to become more environmentally friendly, to become much smarter. And this is basically some of the urban planning around the airport itself in order to ease traffics and also make the journey more pleasant to passenger in this case. Next project I'd like to touch base on very briefly is jointly is a strategic partnership with Siemens. Siemens, as you know, is a major global company. They are pioneers in basically decarbonization, in sustainability, in carbon neutrality and renewable energy. And the aim here for us is to how would we transform our campus to be a smart campus, to be a zero carbon neutral by 2030. So we started here exploring how would we equip our campus with state-of-the-art, basically facilities such as solar panels, battery storage, water source, heat pumps, and so on. And this will be connected to a total management system in order to control the energy. The focus of the project is about reducing energy consumption, producing more renewable energy, and also establishing a living lab which will transform every aspect of the institution, offering the students real life experience of some of these projects in order to prepare them as future leaders in renewable energy and sustainability, which is a key topic of this conference as well. Here is again example of some of the work in terms of modeling analysis in civil engineering, construction, architecture, and that's again in collaboration with industry. Next project, this is a major project. We work in collaboration with Waseda University in Japan, and that's about designing a disaster prevention mechanism against tsunami. We all know that tsunami, obviously, which happened in various parts of the globe, basically have taken away lots of lives. And as a result of that, people suffer. And that's how would we actually be able to do some sort of modeling analysis in order to come up with solutions to address some of these grand challenges human being is facing. Again, here's another example of the morphological modeling under extreme waves when you try to model and simulate that. Again, modeling of or failure of coastal defenses, because what happened is the failure to these defenses. How will you be able to basically design a more robust system against that sort of failure, so it could last longer in this case. We also started exploring more virtual and augmented reality, and we hope from this coming academic year we will have basically a major virtual and augmented reality application in health, in architecture, in construction, across a broad range of area for our staff and students, and also to reach out to our collaborators globally. We build as well the students as a global citizens. And by doing so, we engage them in basically various competitions. And I'm so delighted to report that we won a number of major awards, including the Turner Prize, which is an international grade prize for architecture and in design. We won various RIBA Sterling Award and so on. So it's quite really amazing. And I would like to take this opportunity to thank you for the invitation, for listening, and for this sort of great conference. And I very, very much look forward to invite the rector, Professor Rashid, and all of you to London to have something fascinating similar to this conference in due course. Thank you so much indeed.
Thank you very much, Professor Abdullah. We will come to your university. Thank you very much for such an interesting report. That was a nice report. And I would like to remind you, if you have any questions, to send them in our chat box or ask questions yourselves. So we'll go on, and the next, we would like to give the floor to Vitaly Sergeyev, member of Russian Academy of Science, Vice Rector for Research of Peter the Great, St. Petersburg Polytechnic University.
Thank you very much, dear colleagues. I'm very glad to see, to hear you, and it's very impressive presentation now, Professor Abdullah. I have no such one of my university, but I'm very glad to say on behalf of our university, that it's a very interesting conference. And of course, I understand that always Kazan State University for Architecture and Engineering and Rashid Kurbangaliyevich and Evgeny Dovin, they do their best to organize a very interesting conference, and thank you very much. And of course, I can say that as Polytechnic University, for us, it's very interesting to organize collaboration between universities in different subjects, because we understand that a new problem, new reality, it's Industry 4.0 and problem of decarbonization and new technologies in construction engineering. And we have a great field to communicate. For example, it's very interesting to think about how we can to construct a building on Mars or maybe Moon using materials from this planet. It's very interesting to organize architecture projects with new materials, for example, that to produce energy, to supply energy system when we use this building in operation mode. And I'm sure that all the subject will be discussed on this conference, and best wishes to everybody, and of course health and good luck. Thank you very much.
Thank you very much. Thank you very much, Vitaly Vladimirovich, for such warm greeting. Next, we would like to give the floor and microphone and video camera to Mark Sergely. You're welcome. The UK.
Part of the UK. Just south of Manchester, where, according to the rector, they have the best football team in the world, but discuss. It's always great to work with Kazan and to be involved in this conference. And again, I thank you for this opportunity. I'm going to do a two-part speech actually today. Whenever I've spoken about real testing of roads, I also show different methods we're involved in of the future. So one of the questions I always get asked at the end is about plastic roads. So rather than me today talking about plastic roads, I've, with the permission of you guys, have invited Roddy McEwen from the company McCreeber to first of all talk to you about what he means by plastic roads. And then the second part, I'll actually go on to how we test plastic roads. So with your permission, I'll now pass the floor to Roddy, and Roddy can talk about plastic roads, and then I'll talk about testing. Okay, Roddy?
Thank you, Mark, for the introduction. And first of all, thank you to everyone for allowing me this opportunity to take part in your wonderful conference today. You're all probably wondering who I am and who McCreeber is. Well, McCreeber is a company based in the UK. I'm just wondering, can you all see my screen here yet? Or oh, can you see that, Mark?
It's clear, mate.
Great. Hang on 1 second here, sorry. Sorry about that, technical issues. So yeah, as I said, my name is Roddy McEwen. I'm the International Business Officer for McCreeber. McCreeber has thousands of miles of roads across the world now, and we are currently active in 32 countries at this moment in time. So who are McCreeber? McCreeber is based in Lockerbie, Scotland. It was formed in 2016 after three friends, Gordon Reid, Toby McCartney and Nick Burnett, put their heads together to develop projects to help tackle three world problems. They wanted to cut carbon emissions and reduce the dependency for fossil fuels. They want to improve their road networks, not only here in the UK, but also globally. And they also want to tackle the huge waste plastic problems we all face. So our McCreeber process, all our products are made from 100% waste plastics that would otherwise go to landfill or incineration, and unfortunately quite often into our oceans. So as you all know, plastics in roads isn't something new. People have been adding plastic to road surfaces since the 1930s. Rubber tires soon followed behind that. So here at McCreeber, we thought to ourselves, why are we creating virgin polymers to go into roads when we can't deal with the existing ones that we already have and have been made? A short video here of our process. Our two main products here at MacGregor are what we call MR6 and MR8. MR6 is a binder enhancer, a PMB, a polymer modified bitumen replacement designed to increase the lifespan of the asphalt. MR8 is what we call a bitumen extender. So we're regularly able to 12% of the standard binder content with waste plastics. By doing this, it won't compromise any of the existing asphalt properties, whilst offering a slight increase in the viscosity. MR6 is an arrangement of polymers designed for the extension and enhancement of the bituminous binder. It increases stiffness of the binder and base courses layers to reduce thickness of pavement. Suited to surfacing intersections, roundabouts, slow-moving, heavy vehicle areas. You can use our MR6 product where anywhere a typical PMB is currently required. So what it offers, MR6 offers the flexibility of increasing the high-end temperature whilst remaining the lower end temperature. So for example, when you're looking at the USA performance grade testing that most of the world use at the moment, in general, for every 2% of our MR6 to unmodified bitumen, it will improve it by a performance grade bump. So if your standard bitumen at the moment is giving you a rating of PG 64 minus 22, 2% addition of MR6, so increase that to 76 minus 22, 4% would give you a 76 minus 22, and so on. So here's some information on how it compares to your traditional PMBs. This is from one of our roads in Zermatt in Switzerland, which is fantastic. Switzerland's a great example. So in the winter, they'll typically suffer from temperatures minus 24 to 26 degrees Celsius. But in the winter, it's quite often plus 28 to 30 degrees Celsius. So here you can see that the difference MR6 compares to the typical PMB currently used in Zermatt. And you'll see MR6 offering a higher resistance to permanent deformation, reduction in rut rate and rut depth compared to your typical PMB offering. So here's some examples of where the roads are used for MR6. We use them in HGV lorry parks, intersections, highways, quarries. And going back to MR8, MR8 is a blend of polymers designed for the extension of the bituminous binder. So MR8 would be used in parking lots, city centres, town centres, anywhere where there's no need for a PMB at this time. So here in the UK, it's a very good offering of a product. So we can regularly replace 6 to 12% of the binder content with 100% waste plastics. And by doing this, you won't see any decrease in the quality or the performance of the asphalt. As I mentioned earlier, you'll see a slight increase in the viscosity, but not quite enough for it to be classed as a PMB. So where you would find our MR8 products, well, we're using this with a number of supermarkets here at the moment. So we've got Asda, Walmart, Tesco's, and we're also working with a number of councils across the UK, where we work closely with Durham City Council, Cumbria County Council, and Bristol City Council. It's also used by a number of organisations in the private sectors. So we have Wilmot Dixon, who's a huge organisation here in the UK. We work with Thames Water, one of the biggest utility companies in England. Our products have actually won Street Awards UK for our reinstatement work. So when a utility company will come in and after they've replaced a water pipe or a gas line or new internet cable, they'll quite often use our MR8 product for that project. Our products as well, they're proven to reduce the carbon emissions. So we're an easy option for companies to approach us if they've got carbon targets to meet. It's always at the forefront of any big organization now with any new project that they have to meet a certain criteria in terms of carbon emissions, make the project more sustainable. So by making a small switch to MacReber products from your typical market leader products, we're able to help them achieve everything they need to do. From a cost perspective, it's not any dearer than your typical asphalt at the moment. In some cases, depending on the country involved, it can actually be a saving on the current bitumen and polymer modified bitumen products currently in use. So that's a little bit about MacReber. If you've got any questions at all, which I'm sure you have, to help me answer that a bit quicker, because I'm sure you all guys are all pressed for time today. My email is roddy@macreber.com. Please feel free to send me any questions you have, and I can answer them correctly for you. And I'll pass you back to Mark. But just before I do, just thanks again for allowing me to join this wonderful conference, and hope to hear from you shortly. Thank you.
Thanks, Roddy. So I thought it'd be interesting for you to see some of the different things that as a testing company we're involved in. Just share my screen up. So I work for UTest. I've been associated with Kazan actually for a number of years. My wife is from Kazan anyway, and we've had a good relationship with the university, and we've actually supplied equipment to the university, donated it for future testing. So I'm the managing director of the United Kingdom company. I'm also the global sales manager of UTest. I also operate another one of their companies, CFU. Incidentally, I'm on the industry advisory board for Aston University and the civil engineering department for their new department. We operate globally, and my wife says Kazan is the center of the universe. We're opening an office in Russia, which actually is going to be based in Kazan. We're just in the process of setting it up now. So the network we're expanding is very rapid. We were founded in 2005, two gentlemen who both are still the owners now. We supply test equipment basically all over the world from our central factory, which at the moment is based in Ankara. We've got 140 specialists. There's nearly 400 people working in the group at the moment. And we export at the moment to just over 85 countries. Two divisions, UTest, which is the one that is the main manufacturing unit. And we have CFU, which is the unit which does test equipment for big tenders in special projects, Africa, Kazakhstan and Uzbekistan at the moment. Like MacReber, we're in 85 countries at the moment, and we've actually got offices now in 5, and this will increase this year when I put the Russian office in place, hopefully by middle of summer. In Russia, for instance, we used to sell under own label manufacturers, people like Cooper, we make for Infotest and so on. So we've been around a long time. As I said, the office is about ready. We should be open by June, July time. And the plan actually is to partly make some products in Russia as well, which is phase 2 of the Russian project we're currently working on. Short speech of where we're going is I'm a bridge engineer. I've built bridges all over the world, and I've put the roads on top of the bridges. Sadly, as a bridge engineer, the asphalt was the last part, and it was always the piece that stopped my bridge opening. So it took a while for me to understand asphalt. But I always start with a slide of, the Roman roads 2,000 years ago. Still around, we have them not too far from where we live here, and they're still there. Then we have the roads now with, as you see in the bottom picture, potholes and everything else. That's where technology came. because now we have to build roads to budget, to speed, the cost. We need to combine durability with that, and it's very difficult, we all know. Typically, this is what we see. These roads are cracking, these roads are rutting, and it's part of our problem with all the research, with universities, with manufacturers of bitumen, with other items, how to solve this problem. We all test to current standards, of course, DOS, AASHTO, EN. All done in a laboratory. Well, a laboratory is typically uniform, temperatures, uniform, everything else, and they're all made to certain standards. But as an engineer, we question, are they real? Is that the only method we should work to? And what really is going on outside of the standards? We know we've got the best scientists in the world working on bitumen and asphalt. But as an industry, we need to understand how we can test these skills and how we can advance what they're doing. Test equipment manufacturers like UTES and engineers, we always test from the very bottom of the road to the finish. We are always asked to push a design limit more and more outside really of the standards. So we're having to modify machines that currently work to standards, but then we're asked to make them do something totally different. Currently at the moment, most people in roads, they're using super pave. Balance mix is coming in, historically Marshall mix. But like you've seen with Makriba, there's more experimental ones going all over the world at the moment. So it's what's next. Super pave as a mix, it was designed really in the United States originally for a 60 degrees centigrade road that's straight. And it was supposed to be historical climates in the background and checking the hot mix asphalt and designing it theoretically to meet those climates. But there aren't many straight roads and there aren't many really at 60 degrees. So Canada and other countries began to modify the super pave. So people like Roddy at Makriba, and other people started to modify the original bitumen with polymers, rejuvenators, some cases of engine oil, ground tire. The industry's gone green. It's tried to improve its cost, and it's using a lot of recycled asphalt, certainly over here, which is where the phrase balance mix comes in. Because means that the last 10 or 15 years where we used a gyratory compactor to work on the testing starts to become insufficient. And where people move from super pave to a balanced mix, the testing has to change. Of course, rutting's been reduced by using in super pave because we've increased the aggregate, and there's less bitumen. But the problem is, first of all, it's hard to install. And secondly, as we've all found, it begins to be more likely to crack. But we've had to work to make this balanced mix where we can cure the problems. But how do we test it? And this balanced mix is basically we take the old super pave tests and we add some more tests to it. So everybody uses the wheel tracker, but we need a cracking test, and we've got to work out a system that allows a cracking test to take place. So where we're going at the moment in some of the projects we're involved in, we're having to do an SCB test, a semicircle bend test, as well as the Hamburg test. But the problem is it enough to use the standard equipment? And we found with long-term studies that actually changes are needed to the standard equipment. Of course, like every manufacturer, we have the complete range of material testing equipment, but every day, including this morning before I started, a university asked, can we do something? And these ideas they have don't exist today. They are ideas, But it's a team effort between the industry, the universities, and the manufacturers. Yes, you all see bitumen test equipment. In fact, the RTFO is on the way to Kegasu at the moment, to the university, to arrive in about 2 weeks' time. So we all use the softening points and the temperature tests and the aging tests. We all use the stability tests from Marshalls and the compactions and everything that goes with it, the ABA asphalt analyzers. So we have to make them. We have to make special testing machines for organizations, usually universities, to be honest, or the big bitumen manufacturers. Ridge, well, my concrete. In actual fact, it'll actually test the concrete correctly. The road is incorrect on the brick, so we need to be very careful. The aggregate for the mix is required to be very carefully tested. As I said, we test from the very from the very bottom of the road to the very top. Everything has to be tested. If one item is wrong, road fails. A critical part, which is overlooked, is the soil. Full soil analysis has to be taken out in any road, really. We've had to modify equipment. This one was modified thanks to actually an idea from a university, where it's a penetrometer where we put a handle to make it easier to get the needle to touch the bitumen in the early stages. So it was one idea from a university that told us our machine needed to be modified. Asphalt analyzers, again, they're very popular, they're globally used, but we've had to modify them thanks to ideas coming from universities, really. We have one of these rolling thin film oven on the way to the university now. I think it does leave on the 7th of May. We have to test. It's very easy to test, and although the university will be testing with the RTFO, Makriba also tests the road equipment with the RTFO, the same RTFO actually that's on its way to you. So again, we use universities and industry to test and learn. We've had to modify ring and balls thanks to universities. They wanted speed to be of heat transfer to be changed. We listen. Everybody has to. Universities and users are all important. Everybody, as I said, it's a team. My engineering is, how do I test it for long life? Not always easy in a laboratory. On the right, I don't see a straight road, certainly in the United Kingdom, and never as smooth as that. So we have to analyze 3 different layers, the subbase, the base, and the surface. And as I said, a road actually is soil, subbase, asphalt. And that's really a real road design. We've had to spend a lot of time how we can change design from a laboratory to what's happening in the real world. And as a road engineer, I'm told you really do start at the bottom. Soils, the guys are really important. In the road design, if the bottom is wrong, as you can see from the picture, the road will fail. And of course, the rutting begins. CBR tests are extremely important in initial road design, and it's sometimes overlooked. Engineering-wise, you know, a CBR test is done. We've all seen it. It's a mold. You put the material into the mold and compact it, put it to standards, and then you test it. But by nature, molds have a wall. And in a real life, you don't see walls every 100 millimeters. Therefore, we found in research that the CBR given from a mold can be up to 2% different to CBR found in a real road. We have to work out how to correct that problem. We've had to design, thanks to, well, this one was a university in Ankara, we had to design a machine that simulates a real road test. We've had to do a quasi-dynamic loading test on the soil, basically on the road, where there was no artificial walls. And we used, in this particular design, a lorry wheel. Basically, it was a big CBR mold. It was 1.5 by 1.5 meters, but it reduced the reliance on the wall of the CBR. So therefore, it made life easier for a real road test. In actual fact, the next phase, we put the belt on top, and we're doing a CBR test with the asphalt on top to see what's happening. It's part of a long project. We already test heavily to standards for asphalt, and now people ask me to test differently. We don't get this kind of weather in the UK very often. When we get this weather, we close, we go home, and we stay in bed. But real roads are never 60 degrees, they're never dry all the time, and they're never wet all the time. So standards need to be reviewed. We're working on projects. We don't have steel tires, no studs. And as I said, if the roads are like this in the UK, we don't go out, we can't drive. But we're having to test these now because people in laboratories are asking how we can test to these type of conditions. And we're having modifying machines, ones to be done for Finland, to test for studded tires. We use a Hamburg. People, do 20, 30,000 cycles. We're having to use 1 million cycles to try and copy a 10-year road. We're having to run it dry, and then we're putting spray intermittently onto the dry sample to simulate rain and freeze thaw and drying and everything else. We're having to put, because of, again, it was Finland, they wanted ultraviolet light to try and copy sunshine to try and cause a cracking similar to what we use a pressure aging vessel and RTFO to test. They wanted to test changing wheels partway through a test, but not everybody has rubber tires, so they wanted to stop, put a studded tire on for a while, stop, put an old tire on. They wanted to increase the loads. As loads increase over the standards they wanted to play. We're being asked to change the temperatures, and roads are never at 50. So we're doing one at the moment at -10. It's modifications caused by industry. McCreeber mentioned this on their speech there about junctions. The design mix for a junction should really be different to the design mix to a straight road. Superpave doesn't comprise this. Superpave basically is a straight road. But at a junction, we test different. We had to bring a test in to copy braking because people are braking towards junctions and also accelerating at traffic lights, whatever. So we've had to modify Hamburgs to copy this kind of test. In the Hamburg, we fixed a wheel, so it dragged it across the sample rather than rolled. And it was copying the action of braking of cars. And the reverse action was acceleration. We experimented in the United Kingdom with a testing authority here about use of pneumatic tires to drag it. And part of the experiments were the pneumatic tires will wear out very, very quickly, especially when we're dragging it 20, 50, 1,000 times. So we modified it with a standard EN rubber tire for Hamburg. So we've played, and we do this all the time, and we welcome all the discussions. And it's part of, again, this partnership between the industry, the universities, and the manufacturers. See a lot of problems at the moment here on cornering. And it's the same problem. We have to understand what's happening to the road and what's the dynamics of what's going on. The aircraft on the left, actually, Heathrow Airport have a problem where they used to push the aircraft back. It was being loaded with passengers. Where they were pushing back, it was the special machine to push it, but it was actually ripping the asphalt, and it's now a concrete stand. So we're actually playing with an experiment with them at the moment. So we had to design scuff tests for cornering. So instead of a Hamburg with a straight wheel, we had to turn the wheel at an angle and basically drag it. So again, this was brought in with ideas from industry and ideas from universities. We're having to do real road testing with heavy loads. We're making an asphalt sample instead of 50 mil or 100 millimeters thick. It's 300-400 mil thick. We're trying to create a real road on a little machine. This project was actually done in Russia. We're playing with additives. This one's Tensar. So people asked us to overload a sample with a Tensar matting to see what happens. Again, it was a research project, and we played, but we tested it to double the normal standards in loading, and we played to see what happened. Other pieces of equipment, pave testing. You'll see this is a machine with 7 rubber tires that rotates round on a sample. It's a bigger sample. It's typically 1.5 to 2 meters long by 500 to 1 meter wide, and it simulates a real road. It can't do wet, it can do cool, but it's again part of the process of industry where we're testing real roads in a laboratory. Universities, you're coming up with some really strange inventions at the moment, and it's really good. It's interesting for us, and we get involved in some really odd ideas, and it's happened. We're involved in, so at McCreever have some of our equipment they're testing up there, but we've also been involved in the United States with a porous road, and in Holland, a simple plastic road, pure plastic road for cycles. Robbie spoke about McCreever, so he can go through how it's been tested. I know the initial design of the McCreevers was done on a Hamburg as well, so it's part of the system. As well as McCreever and plastics, we're involved with companies that manufacture aggregates. So they take waste, similar to McCreever's idea. McCreever take plastic waste, OTA take the other part of the waste, and they create calcium carbonate, limestone, which we use a lot in our roads and concrete. So we're involved in testing there. It's a big organization now, and they're making roads, and we're having to change the standards of what we're doing with our machines to do these roads. So it's a joint venture. It needs innovation. We need to work out what the failures are, and we all have to try our best to work as a team across the network. As I said, it's a partnership in testing. According to my boss, you invent it and we'll test it. McCreever have already tried. Okay.
Okay, Mark, thank you very much. And your colleague, Rudy, thank you very much. That was very interesting. And I think that was very useful report. Thank you. We have questions in chat box. All the thank yous, all the, I don't know, kind words. Can you please answer these questions in chat box? If you're ready to answer them right now, you're welcome to answer them right now. But I can see that Rudy has already answered a few questions, and there is another question. How would it be convenient? Answer here or in chat box?
I'll answer it in chat, and everybody's got a note of it, if that's okay. It makes it a bit easier, and I'll let you continue on your great work and presentations.
Thank you very much. That's good. Thank you. Thank you very much. And we continue our conference, and the next we would like to give the floor to one of our professors, Associate Professor, PhD, Arslan Ziganson. Arslan Malikovich, are you here?
Yes, I'm here. Hello, everyone.
Yes.
Did you hear me?
Yes, we can. We do.
Okay.
You're welcome to start.
Thank you very much. Hello, everyone from Kursk. We're here on the Olympiad. I am PhD of Kazan State University of Architecture and Engineering. Now I try to so that's my presentation. I would like to present you my scientific work. It's called Improving the Energy Efficiency of Ventilation Systems by Shaping its Duct Fittings. The ventilation systems is most efficient but also energy-intensive way of trapping pollutants and creating sanitary standards for indoor conditions. When air moves through the air ducts of ventilation systems, a large amount of energy is spent, and most of which is spent on overcoming so-called local resistance or pressure or duct loss in the fittings of duct systems, which occurs due to deformation of the flow and the vortex formation near their sharp edges. Therefore, the elimination of such zones, vortex zones, and accordingly the reduction of the energy consumption of ventilation systems is an important task. Reduction of resistance fittings is possible in various ways. For example, by rounding and large radius of rounding lead to a significant reduction, but at the same time to the increase in the sizes of the systems. Therefore, in usually cramped placement conditions of ventilation systems, they are not used in practice. In addition, it is possible to use various devices such guide vanes, transfer ribbing, suction or blowing of the boundary layer, and others, while this way of optimizing fittings will lead to more rises to a more manufacturing complexity, manufacturing technology. So problem of reducing the resistance is important, and the existing methods of solving due to complexity or leading to size increasing are not used in practice. At the same time, it is possible to reduce the resistance of parts, ventilation duct fittings, without complicating the technology and increasing its dimensions, due to the shaping of the duct fitting elements along the outlines of the vortex zones. According to the peculiarities of formation of vortex zones, all fittings can be divided in two large groups: part with separation or merging, or parts without separation and merging of the flow in them. Some of the most characteristic shaped elements from this point of view are considered in my research work. Without merging, the last exhaust opening and sudden expansion, and merging T's and merging T's and middle exhaust openings. The study of the current state of the issue of flow characteristics in such duct fitting elements show that despite of large number of works, they contain only fragmentary studies of vortex zones, and there are no studies on the use of their outlines to shaping and reducing its resistance. The information I found in the literature on the local drag coefficients, the lengths of the vortex zones, will be thoroughly used for validation, setting up computer models and checking the results obtained. So main goal of the work is to develop, using the methods of computational fluid dynamics, the basics of calculating and designing of aerodynamically improved ventilation ductworks that reduce the total electrical consumption of the ventilation systems. Methods have been developed to determine the local drag coefficient due to this research work, the length of the influence zones of the duct fittings, which is a disturbing element based on the result of numerical studying using the ANSYS Fluent Computation Fluid Dynamics software, and founding the outlines of the work of the vortex zones. According to the results of preliminary studies, it was shown that although the vortex zones is three-dimensional and shaping along it leads to an additional decrease in the local drag coefficient, its value is not so significant, and the difficulties in the study, and more importantly, in the manufacture of such a surface, make the use of three-dimensional vortex zones for shaping irrational. Therefore, further will be carried out two-dimensional and axis symmetric studies and the development of elements with their use. The carried out numerical studies are verified experimentally on two experimental setups. For exhaust hoods, measurements of velocity fields at suction and visualization of vortex zones. And for the other fittings is resistant on this experimental setup. Here we measure the resistance and visualize the vortex zones. Next, I briefly shows the main results. For the exhaust middle lateral orifice, we investigate and found outlines of the vortex zones and based on these outlines we research the computer models of the shaped construction of this orifice and we'll see the local drag coefficient reduction about 30 to 75% determined. For the lateral orifice, the same research done, and we found the outlines of the vortex zones, validate the due to experimental visualization, and done the computer simulation, and found the dependencies for local drag coefficients, and for the shaped construction, we obtained the reduction of the local drag coefficient about 20–30%. The same research we done for the exhaust round hood, obtained the vortex zones. There are two vortex zones at the entry to the exhaust round hood. First vortex zone and second vortex zone, the zones, the sizes and dependencies to determine the sizes, and with use of these outlines of vortex zones, we determined the reduction of local drag coefficient about 40%, that depend on the sizes of round hood. The same research was done for the slot hood, both numerically and experimentally, and here the reduction of drag coefficient about from 10 to 70%, depend on the size of the slot hood. For the non-symmetrical T-junction exhaust T-junction. We obtain the vortex zone, local drag coefficient, both numerically and experimentally, and for the shaped T-junction, we have about reduction about 60%. The same research was done for the southern expansion, and here reduction of a local drag coefficient was about 80%. For the use of the developed energy efficient duct fitting, the following scheme proposed. The designer at the stage of tracing the system selects the necessary fitting elements, and for its specific configuration according to the graphs and dependencies determined in this research for the shaping, and transfers it as a file to the machine for cutting sheet metal, and where further, according to the usual standard technology, manufacturing of duct fittings, it is cut and manufactured, and that is the resulting energy efficient element is not more expensive than the standard one. According to the graphs and dependencies of the online calculator, local drag coefficients for the energy efficient duct fitting is determined, and carry out the standard aerodynamic calculation. The result is a system with reduced energy consumption, and if the system has a large branching and there are many fitting elements, then a pressure drop decrease, and it can lead not only to decrease in operating costs, the electricity consumption, but also to a decrease in the size of the fan, and that is a decrease in capital costs. In this work, using some example of two variants for aerodynamic calculation of air ducts, medium sizes exhaust ventilation systems, we obtained the aggregated indicators for the possibility of estimation calculation of the effectiveness for the use of shaped energy efficient fittings without this complex numerical studies. And it is found that the reduction in resistance for public buildings is about 30 to 50%, which leads to decrease in electricity consumption in general by about 22%. These values was confirmed when implemented at a real facility. It is an office center in Kazan with an area of 20,000 square meters urban, the first in the city to be certified according to the A class of energy savings. As a result of implementation, this research work for this building, for the main 10 exhaust supply ventilating systems, led to decrease in electricity costs in prices of 2018 in Kazan by 300,000 rubles and about 27 kilowatts electricity consumption, and the decrease in what's going on, and decrease in capital costs by about 700,000 rubles. Sorry. In addition to the method of shaping the channel wall of duct fitting elements for cases of reconstruction of systems where it is not possible to replace the element, the whole element. It is possible to use a shaping insert in the channel. The insert itself can be made of plastic materials or sheet metal and installed inside. A patent for this invention was obtained, and there are some registration certificates for the models of the online calculator program. The research results reflecting the main result are presented in 19 journals in the peer-reviewed scientific publications by the Higher Attestation Commission of the Russian Federation, and 7 in publications indexed in the Web of Science and Scopus databases, quartile 1. Thank you for attention. Glad to answer to your questions.
Thank you very much, Arslan Malikovich. That was interesting presentation. And if you have any questions, you can see all the emails on your screens, or you may ask your questions in chat box here. If anybody has question or questions, maybe you're welcome to ask. Okay, Arslan Malikovich.
Thank you very much. Thank you very much.
That's great. Could you please switch off the presentation? Thank you.
Thank you.
Great. Thank you very much. And now the next presentation, the next speaker we would like to give the floor to is Peter Larkin from University of East London. Peter, can you hear us?
Yes, fine. Can you hear me?
Hi. Hi. Ready to start?
Yes, just about. I just need to share my screen and things. Right, where are we? Full screen.
Is that University of East London behind you?
I have, yes.
Okay, great.
I'm in the airport, you see. It's waiting to come over. Yeah, so can you see my screen? Is the yep, you should be able to. Yes. Right. Okay. So good morning from London. I'm Peter Larkin from University of East London. And thanks for inviting me. I've been invited to present to you today some of the recent developments in digital construction. BIM's been around for a while now. We're getting quite used to working together. And the biggest thing, of course, is we're working on this common data environment so that we can all share the data. There's a huge number of software packages now available, and the important thing is they all need to work together. It's not just the people, it's all the programs and all the computers need to work together too. So yeah, it's this common data environment. It's a term that keeps cropping up when you're talking about BIM and current situation. To help things along this year, we saw the introduction of an international set of standards, the ISO 9650. And this basically shows that we get this interoperability working between us, especially when design and construction teams, like they are now, are so multinational. And we will need to work to the same standards. So yeah, we have gone from what we had as a good English British standard, and that's now been adopted and amended to be used throughout the world. It's a very good system. So we are looking now at the next level of BIM. We've looked at level 2. We've been with BIM on the cloud. The dynamic data, and there's a big movement at the moment is to drop the idea of BIM. BIM will stop at level 2, and this will now become just digital construction. And as Hassan said earlier, part of Industria, part of Industry 4. The next big leap forward in computing and the way computing affects everyday life. So the idea being is now that the data will be stored in the cloud, so all stakeholders can access at the same time, and any teams can work together as we have here, or simultaneously working on the same set of data and be able to discuss it from wherever they are in the world. The Internet of Things is another big, is developing fast. So it's got this embedded electronics. We have software, sensors, actuators, and all connected through a network, which is based online. And then all the objects that are involved can collect, exchange data, and be controlled, have control across the internet. So far, we've seen that in smart buildings where air conditioning and the lights and the heating is all controlled remotely. That's now becoming, I mean, the next stage is going obviously to be smart cities, which we've been speaking about for the last couple of years, where far more of the city is being controlled to help out. That's a complete discussion, complete presentation on its own. What we're ending up with and what we're looking for now is the new term digital twin, which is basically the virtual version of a two-way link to this physical world, so we can control it. And that's the big new term coming up now over here, is digital twin. In other words, it's really just a dynamic BIM where all the information is changing continually, and we can monitor it and change it remotely. Right, we all know that the basis of BIM is a good 3D digital terrain model, which requires either a topographic or a measured building survey. So here we have the old way, a total station picking up 3D points, and just like GNSS, been collecting 3D digital data for many years. Nothing new there. Recently, though, we have added scanners to the surveyor's equipment list, which produces a point cloud very quickly. Some of them now over 1 million points a second, which when you think we were doing with the total station 1 point every 8 seconds, it's a bit different, really. Once we've got the points, thousands, billions of points, we can actually go in, interrogate them, and find things like distances and areas. And even if from that, we can then use those measurements to start creating models, BIM models from real life, with the real measurements, without actually measuring them physically by hand with a tape like we used to. We can take the measurements direct from the point cloud, which is very, very useful if you don't have direct access to what you're trying to measure. Latest idea, though, is not to produce a BIM model of the whole structure, but to save time and money, you just model the items of interest, the bits you're going to need. It's a process we call hybrid. It's a mixture of point clouds and BIM elements joined together. So here we have an old heritage barn that needed work on, scanned the barn and added the beams to show where the new work's going to be without modeling. It's impossible to model something like that. It's so irregular shaped that it drives the computers crazy. So we don't. We just use it. We add to it. So as I say, it's called a hybrid. Next stage, of course, is to put the scanner on an aeroplane. We can increase the power and then point it at the Earth, and we have a LiDAR. And a LiDAR produces a point cloud over a large area, which is very good for projects like town planning, sorting out roads and railways, new routes for them, and also, of course, a big area now of flood predictions and working out where to put the defences. So a lot of work going on there. Scanners are now being put onto cars. As you drive along, you can pick up the scenery along the route. The key items here, though, is not just a scanner, but it needs to have the GPS receiver, which records the position as it continually changes as it moves along the road, of course. And it's got 3 scanners, which are all pointing in different directions. One in the front, one to either side. And then in this cab, when you're driving, you can see what's going on and control it from there. Surveys from that, like these roads here, used for highway maintenance, updating maps, but really look, some of the views, some of the output they're now getting is actually quite stunning. They make good pictures. So somebody said the other day to actually, oh, why don't you print those out and put them on the wall? They're far more useful than just that, though. In addition, you've got now ground penetrating radar, and that can now be pulled along by the van, by the vehicle. In addition, it picks up under the ground all the services, all the utilities, or any voids, anything it finds under the ground, and then it can basically add that to the 3D model. So we can start working around that, and our new designs, any designs can actually link into the existing services without putting any, without accidentally cutting into any. Another survey method that has seen recent revival due to improved computer technology is that of photogrammetry. This process is achieved by choosing, say, the same point where it appears on different stereo photographs, and then we can create a 3D model by joining up the points. And here we have a very old, this is about 20 years ago, we were able to do this and create a 3D wireframe model. Now we can take it and get a good rendered image. As you can see here, the white squares are the positions of the photographs, and then we can pick up the model, create the model from those photographs. And here's what, from there, it can create a 3D mesh, which obviously you can see there being 3D. You can take the measurements from it, or you can get a point cloud and drape the pictures over the top of it to get this realistic image. So here's one I did when I was in Kazan last. The youth theatre, we had a visit, and some of the work that he's doing there. So he created a 3D model, and you can say, look, absolutely stunning picture there. 3D model is quite clear. You can see behind the columns. But don't forget, I can go in there and take measurements. Right, another new effort, another new development are drones. Unmanned aerial vehicles, to be precise, drones for short. You can put the camera into the air with a pre-programmed route to ensure 60% overlap, and from that you can produce a 3D model, a CAD model there, which can go in and be again your basis for your BIM, for your drawings, for your design. But of course it gets better than that, because rather than just a point cloud or photos or 3D mesh, put the photos over the top and you can get a real life image just to see what it really looks like. Very useful to work on. Right, onto the construction site. I'm going to leave out design aspects because we've been doing it for years and years and years. So we don't tend to pick up on these other items. So what I want to do now is have a quick look at where BIM is working on building sites and what we're doing, new things there. So total stations now can link straight to the BIM. And here we have one of the image total stations, and you can see on the screen the BIM with all the points highlighted, and you can go and set out those points one by one in 3 dimensions. It's the same with GNSS or GPS or GLONASS, where you can pick up points and locate the points and put your pins in if you need to. Other similar vein is this TopCon 3D Layout Navigator, and this provides a laser point to indicate where to build. So rather than putting pegs in, you get a little red dot, and that's where you can build. saving a lot of time and materials on not using pegs anymore. This same technology can further be used to control on-site plant, such as bulldozers. You've got a bulldozer here, 6 or 7 sensors have now been added to it. Those sensors are linked to the Internet of Things, which means that the BIM can be transferred straight into the cab, and the driver can see where to dig and how many paths, how much material to move. It's exactly the same for the excavators, how much to actually dig. The whole point is then that that digger can basically work with the model to get it right first time. The software that's used is just one example called Dynaroad from Topcon, looking at the BIM. So you've got the BIM model there, and that is working directly then to the cabs, to control the cabs of the excavators, the bulldozers, the earth movers, all controlled directly. Of course, this has major savings. If you get it right first time, you've made such a big saving in waste of materials, and waste of time, waste of fuel. But also, of course, you've got the safety aspects, where you've got the safety. You're not going to have this surveyor standing in the way anymore, who's likely to get thumped by the excavator. It's not needed anymore. So safety first. This, of course, leads now on to why have anybody in the cab at all, and autonomous vehicles are being trialled quite a lot as we speak. These are huge, great quarry diggers, and there's nobody on board. No, they're very good then for working in dangerous areas. Yeah, we're driving it from the office. You're not in the cab itself. Robots then, is carrying on with the idea of automation. Robots are being developed to replace jobs that are really monotonous for humans, such as here, repetitive bricklaying, or say heavy lifting, even tying rebar can all be done by robot now. Now, many doubted these developments as their usefulness on site because of the setup costs and everything, but we're seeing lots of this modern methods of construction providing precast units made in a controlled environment of a factory where they can be made by robots and then just assembled on site when they get there. So this whole idea of robots and automation is becoming quite a big thing now. 3D printing, for example, has progressed from little plastic objects to full-scale concrete components, printed in the factory, transported to site. There have been some attempts to print in situ, like, say, this house in Minnesota, but more practically, there's a good one in Apiscore House in Stupino near Moscow, which was built on site by this arm printing in concrete. The largest building so far that's been printed like that is an office administration block in Dubai, absolutely massive. So it's with us, it's a new wave with us, and very quick. Who knows? We could be leading the way to robots printing homes on Mars, ready for the first settlers, as somebody mentioned earlier. All this site work still needs monitoring. Crane cameras, where a camera is placed on the arm of a crane, photographs taken at regular intervals as it turns. Can't do it on a daily basis. You get a look at the progress of the site, but you get it in 3D. It's like a time-lapse 3D rather than just photographs. Drones too are beginning to have an important part to play on sites, providing instant views for site meetings. So the team are in their respective offices being fed live information from the drone, and then they can discuss and carry out immediate action about what they find when they see it. So rather than just sitting in a stuffy site office now, everybody is no traveling costs, much easier, and you can see instantly what's going on. Drones like this for checking were used consistently throughout the Crossrail project that Hassan was talking about earlier. They were flying these little drones up and down, taking photographs inside the tunnel the whole time to keep tabs on it, to see what was going on. Augmented reality, another mention. Somebody said, I think Hassan said earlier, this provides a view like this one here, projects the BIM into the real world by using a tablet, and you know where to build. It could be doing, you know, same work, showing somebody where to build, what it's going to look like. It could be looking for underground facilities, laying that BIM on top of the real world, so you can see where the pipes are. And also on-site verification to add the BIM into the real world so that you can see if it's been built properly or not. Now, of course, we've been using tablets. Why not put it into your helmet? We've got Google lenses have come out, and this is a Holo Smart lens or a Daiquiri Smart helmet here. The advantage is it's on the screen in front of your face. You've still got both hands free. What you actually see is something like that, where you've got the 3D model. There, you see the 3D model as a mesh there, overlaid onto the real world model, and you can therefore see what's going on in real life and in the BIM at the same time, which basically gives you the chance, as I said, to see where things are going to be or whether or not they've been built correctly. Smartwatches. Yeah, funny we have smartwatches on a BIM project, but yes, they can be linked to the BIM. They measure things like heartbeat and temperature, so if there's a problem with the person, the office gets signals straight away. They can locate the person and send the emergency services straight to that person. And also, if the site needs evacuation, then they know where everybody is. They know where everybody can come off very, very quickly. And finally, we've got the exoskeleton, takes the pressure off various muscles, give more power, especially when working overhead. In fact, we've been told, well, when you hold your hands up, it's actually easier to hold them up. And it pushes, it's hard to keep your hands down. And you can work with your hands over your head for a good couple of hours without getting tired, which has never been before. Anyway, what I want to do is leave you now with one of my students. This is Grace. Last year, trying on this equipment. Basically, what I'm trying to say here is that all the stuff I've mentioned may seem to be futuristic, but look, they're with us already. They're on the site. I think this is getting to be a very exciting time for the construction industry. So let's see what happens. And thanks for listening. Any questions? Wake up, Mary. Right. Any questions?
I'm sorry. I switched off my microphone. Sorry, but I'm here. Thank you very much, Peter. That was interesting and useful. Very much. Thank you very much. If there are any questions, they will be in chat box, because as I can see, there are no questions online. So please check the chat box and answer the questions if there are any. And we go on, and the next speaker is Nikolai Vatin, Doctor of Science, Professor from from Peter the Great, St. Petersburg Polytechnic University. Nikolai Ivanovich, you're here? Could you switch on your microphone? The microphone?
Hello, hello. Do you hear me?
Yeah, it's okay now.
Yeah, that's good. That's great. That's great. It was a good pleasure, a big pleasure for me to have a possibility to report on your conference. And my report is after greeting words from our Vice Rector for Scientific Research, academician Sergeyev, and it's a good support for me, And I tried to start, I tried to share my screen. Could you okay, do you see the screen? Do you see the presentation? Have you got the screen? Or not?
Yeah, we can see the presentation. It's all fine.
Oh, that's great. Let's start. And the topic of my report is dynamic stability of viscoelastic plates of variable thickness. And I'm Nikolai Ivanovich Vatin from Peter the Great Polytechnic University, St. Petersburg, Russian Federation. And that's my contact information on the screen. What I'm going to speak about dynamic stability. And there are, and already we may say there was, 2 submissions and 2 reports from our team on this conference. One is parametric vibration of viscoelastic rectangular plates with concentrated masses, and another one on stability of viscoelastic plates variable thickness under rapidly increasing compressive load. You see that in both cases we are speaking about viscoelastic and plates, and both plates are thin plates, thin-walled plates. And our team is from 2 countries, from Uzbekistan, from 2 universities of Uzbekistan, from Tashkent Institute of Irrigation and Agricultural Mechanization Engineering, and Tashkent Institute of Finance, and from our St. Petersburg Polytechnic University. I'm not going to report these 2 particular submissions for second time. I'm going to show some common approaches to solve the dynamic stability of thin-walled structures. And where could we see the thin-walled elements in buildings and structures? Well, first of all, we should understand that there is a lot of dynamic loads in a building and structures. What is there? There are wind loads, and when we're talking about wind load, there's static part of wind load and dynamic part of wind load, which are coordinate with turbulence. And in a case of large vortex, the dynamic part of load could be more stronger than static one. Of course, the dynamic, typical dynamic load is quake dynamic load. Sometimes we must to calculate our structures under the impact load, and a special cases is a special case of impact load is a ballistic load. And where is thin-walled elements in a building and structures? What's that? Well, first of all, thin-walled rods and beams. Typically, it's a cold-formed galvanized light steel structures, which are now is very common using. There's the second, thin-walled plates with constant and variable thickness. In many cases, we use thin-walled plates. Even in one of previous report, there was a ventilation system with ventilation channels and chimneys made of thin-walled steel. It's a typical thin-walled plates with their own dynamics could produce, for example, an acoustic noise. And thin-walled shells with and without internal ribs, typical part of structures of typical element of buildings. And what is the study of parametric vibration on thin-walled structures? First of all, it's a separate research area of general mechanics of deformable solids. And the solution of this dynamic stability include in yourself, first of all, derivation of equation of motion, motion equation, discretization and calculation of this motion, as typically it's used some computer calculation, and determination of areas of dynamically instability of the structures. Let us see the typical civil engineering approach for dynamic stability and instability. We will know from, for example, from building mechanics, this kind of equation when U is displacement and Q is external dynamic load. And how is typically way to solve this this equation of motion, this equation for which connect external force and displacement? Typical ways is represent external force like a harmonic force. And then equation could be motion to well-known form like this. And this equation is typically determined using a method of spectral decomposition in a row with very large, an infinitive number of members. And using the finite element methods, FEM methods, we typically try to find the solution of this row to analyze the static and dynamic of building and structures. We go with unlimited number of members of this row to some limited to n number of members, and this formula, this equation, is the most frequently used in FEM calculation programs. And in Russian, there is such program as SCAD and Lyra. They use this way of solving of motion equation. What's the problem for engineer? He should choose the level of the number of members to calculate dynamic stability, dynamic behavior of the structure. It's quite typical when they use 5 members, 7, 6, 9, and doesn't change. And engineer could say to himself, yes, okay, that's enough. But nobody knows what will be happened when the n became equal to 15, for example, 25. And every step, every rising of number of these members take very high level calculation efforts, which are use time, computers, money, and so on. What the modified civil engineering approach? The modified civil engineering approach is quite easy. They use a limited number of numbers of this row and use some additional part of the equation. This is part, the first one is a dynamic solution of a previous equation. And this is a static, we may say that is a static solution of very similar equation of motion. It's quite typical way to solve the problem of number of members of row. What I should put attention on you, that's a simple illustration of this approach on a simplest situation. That's a beam or a string. Well, it's a solution with limited number of row numbers, and this some additive, which use not a dynamic but more easier finding static solution of equation of moving. That's the idea. Generally, it's not a new idea, but there is a new approach which was made in our university by Vladimir Valin and Lehr, and they have a previous publication with this DOI number, and there is some article in press by these authors. And for persons who interested in this topic, I could provide with this article in press by your demand. But this approach based on row equation doesn't work good with the plates and shells. They need some separate solutions, some separate research, separate from all another part of buildings or structures. And that's the typical task of symbolic structure elements research in a geometrically nonlinear formulation for the mechanical deformable solids. The properties of orthotopic viscoelastic rectangular plate is as follows. First of all, plates materials. It could be elastic or viscoelastic, and viscoelastic made the finding of solution more and more difficult, more and more heavier. Typical is rectangular form. We try to solve task for variable thickness. The load supposed to be periodical. And of course, we try to solve this task for different boundary conditions. The edges could be supported or clamped. And there is 3 steps of this solution. An analytical numerical method was used to solve this problem. The idea was from Professor Abdikarimov from Uzbekistan, and he do it and we do it in a 3-step. The step is as follows. First step is quite standard. It's a mathematical model based on Kirchhoff-Love hypothesis or Kirchhoff-Love theory, and the equation of moving looking like that. It's a quite well-known approach. And this equation are supplemented by corresponding boundary condition and initial condition, because we try to solve this task in a non-static approach, non-static formulation. The second step is a solution method. The solution method is the main part of this idea, because we use Bubnov-Galerkin method based on polynomial approximation of deflection and displacement. And the next step is a discretization, and the next step is digital calculation, based on using a weakly singular kernel, because we use weakly singular kernel and we use integral differential equation system, not a differential, but integral differential equation system. And the type of weakly singulation kernel is a Koltonov-Rozhanitsyn kernel. And it's better make a remark that Koltonov have most of his books published in Tashkent, in Uzbekistan. So we could say that Koltonov mostly an Uzbekistan researcher, Uzbekistan scientist. And some note for those who want to follow this method. Typically, in a most publication, using of Koltonov-Rozhanitsyn kernel is often referenced to a tutorial, to a textbook, which are issued by Vysshaya Shkola in Moscow in 1976. But in fact, Koltunov published this kernel 10 years later and published it not like a tutorial, not like a textbook, but like a research article. That's the information, that the link to this research article with DOI number, DOI index. I don't going to put into detail, but this method, this 3 steps approach, give us possibility to solve this task in non-linear formulation, non-static formulation, and we get, for example, we could see the influence of viscoelastic properties of materials in comparing with elastic properties. We could calculate and we could see the vibration modes in elastic and viscoelastic plate situation, viscoelastic materials of plate. So we get some advantages of these proposed methods. What the idea? We compare this method with a typical Maxwell or Kelvin-Voigt equations or so-called standard solid models. They are quite simple and quite most used models, most used by many researchers. But this models based on the solving a differential equation between tension and displacement, and they are very strong. They are in a very strong dependence of the initial conditions. Using differential dependence give us some mistakes which are especially could be mentioned on the beginning of the calculation, and they come to accumulation of errors. So it's, in fact, it's quite difficult to get the good results using those simple approach for the difficult task. For example, for very thin plate with a non-constant thickness and so on. There's no accumulation of errors in integral relationship, which we get using the singular weakly singular Koltunov-Zhanisyn kernel. That's the advantage of proposed method. And I may say that this method gives the results which are in a good, or I may say not bad, coincidence to reality, to experiments, and not bad coincidence with the other strong calculation. We are ready to cooperate. We are ready to cooperate in a following forms. We are ready to cooperate to have a joint research. We are ready to cooperate to have a joint publication. And we are ready to cooperate for joint application for grants. That's a repetition of my contact information. Thank you. Thank you for your attention.
Thank you very much, Professor Vatin. That was a wonderful presentation. I think we will join the research, the publication, and grant programs. Thank you very, thank you very much. Okay, great. So, and again, questions, if there are any, you may ask them right now, or just send them in our chat box. So, I don't see any questions. We go on with a next speaker, and that is Stefano Bertocci, architect, full professor of Department of Architecture DIDA of the University of Florence. Stefano?
Hello, I'm here.
Hi.
I start the contribution of the... Many greetings to everybody for this invitation. We have a long time friendship with the University of Kazan, and we have participated in so many initiatives. We have done also a workshop with the students. So thanks to you for this invitation. Now I try to share the presentation. You can see the presentation. Please, you can see the presentation.
We can hear you and we can see the
Okay, thank you very much. Sorry. Now, the topic of my presentation is the activities of my laboratory of architectural survey and 3D digital survey. The laboratory is part of the Department of Architecture of the University of Florence, and involves some professor and researcher in these activities. We have several cultural relationships with several institutions and foreign university as Kazan State University. So years of experience in the field of survey, in defining political, scientific, and technical tools for the protection of cultural heritage in Italy and in Europe, shows that the process of cataloging has to be increasingly necessary to activate more integrated and technologically advanced systems for the protection of cultural and artistic heritage. The main idea of this research laboratory relates to the possibility offered by the evolution of technical sources in the field of survey and documentation, and the creation of a computer application to support the operational requirements of the conservation project and restoration project for archaeological, architectural, and urban heritage. We have seen before the speaker talking of hybrid model in HBIM, using the clouds of point and the result of digital survey for defined by BIM activities. That is one of the tools that we can use in these methods. But some words about our tools. We have seen just something about this. The 3D laser scanner is a technology improved the acquisition fitness of thousands of points per second of the geometries of the detected object. This kind of instrument performs the 3D scan that creates clouds of points. The basic principle is the emission of a light signal laser by an emitter and the receipt of the return signal by a receiver. The final result, as we can see in the previous conference, is a 3D clouds of points, representing the three-dimensional space around the scan station, characterized by high accuracy, useful to extract, for example, in the process of conservation or restoration, 2D or 3D representation, or 3D models as we have seen before. We can see here also some other tools that work with photogrammetry, like these 3D eyes, that is a new solution for use three-dimensional photogrammetry on narrow space or in the interiors, where we can use the drone, for example, the drone that we can see here some samples of photogrammetric tools, photogrammetric results by the drone activities. It's now clear that a careful analysis of the survey assessment data plays a fundamental role in the protection of cultural heritage, and is the preliminary step for a sustainable and organic strategy for conservation projects. The knowledge is the necessary premise for the preservation and the enhancement of specific, especially for architectural and archaeological heritage. The accuracy of the documentation like we have seen with these specific tools, becomes even more important when the policy of conservation concerns both the physical objects, as project of restoration, conservation, and so on, and also immaterial memory of the historical, artistic, and cultural artifact that retains its value over the time. Now we can see here one of our project about the Church of Transfiguration in Kiji Island in Karelia, Russia. The subject of the research was the Pogos complex located in an island by the Onega Lake in the Republic of Karelia. The study has the aim of precise, detailed, and accurate analysis of architectonical and static structure of the Church of the Transfiguration for the development of methodologies for its conservation and restoration. This study focuses on general survey of the object, two different methods. This laser scanner survey, direct survey, because inside of the roof it's very difficult to come inside with the machine, and general analysis of a wide photographic and photogrammetric campaign to detailed drawings for studies from general to the particular analysis. The final results in this case consist in the traditional 2D drawings and the digital modelization for example, for a three-dimensional reconstruction, and in this case, a 3D model for the structural analysis. Some example in other cases, like this in the Verna Sanctuary in Arezzo, I want to show you an alternative use of digital survey and especially clouds of point in the field of communication of cultural heritage for the conservation of the imaging of the cultural heritage. We can fly through the clouds of point. This is a clouds of point in not true color, in a false color, but it's important to have an idea of the environment of the complex and of the architectonic importance of the complex itself. Here we can see the road, the main road inside, and the ancient road that reach now the convent. Here we try to compare, for example, this experience with the experience of the masterpieces that are inside, that are conserved inside the church. In this case, in La Verna, we have the most important collection of the La Robbia reliefs, and we can see here that we can add content. For example, in this virtual trip of the inside of the church, we can add more specific content about the survey, the 3D representation, the 3D model of one of these samples of the masterpieces of the La Robbia that we have conserved inside of the church. This is important. This is a very important system for the dissemination of the value of the cultural heritage. In this case, this is the Herod's fortress in Masada, Israel. We have surveyed all the fortress for the local administration for the Masada National Park. You can see that the fortress lies over the top of a very hard rock, 14 meters over the Dead Sea. The research program for the documentation of archaeological site of Masada has provided survey campaigns organizing along 3 years of activities and thematic seminars with the students and researchers of the University of Florence that works together with the local students of Schenker College in Tel Aviv. It's important here, one example, how we can extract the mesh models from the cloud soft point. Certainly, we don't using everything, everything, all the data. We have to decimate the data set, but we can see here how it's very involving for the visitors, also online for this site, the virtual visit of the 3D models, where we have applied the photogrammetric survey over the cloud soft point, and we have already the result of a colored model that has not a good level of details to document this very important archaeological remain. Another example is the Trugir UNESCO Center. Trugir is a place, is a little town, a very ancient town near in Croatia, near Split. The workshop relating to the survey and documentation of Trugir consisted the first international cooperation experience between DIDA, Department of Architecture of Florence, and the Faculty of Civil Engineering of Split. The research deals the analysis of an area inserted within the tourist city of Trogir, whose medieval historic center, a UNESCO World Heritage Site, has developed on a small island on the northwestern entrance of the Bay of Castles of central Dalmatia. It's about 50 kilometers west of Split. Here you can see the result of our work of survey, that is the documentation of all the waterfront system, and analyzing the principal monuments that we have all around. This is very important also to verify the impact of the tourism in this very precious area. You can see here the survey of all the what it happened in the sort of center where we have a very big influence of the tourism, a very big not so good influence of the tourism. Each one of the buildings is devoted to the tourism. Each one of the surfaces are devoted to eating and restaurant and so on. So it's very important, this kind of analysis, to define the sustainability of this kind of tourism, and especially now that we have to plan, as in this case, some activities of conservation of this waterfront, and we have to, in a sort of cleaning of this waterfront, to return, to come back to the original imaging of the town from the sea, from the harbor. You know that each one of UNESCO site have to prepare a plan for the management of the site. And this is very important documentation for the management plan of the site. Here we have another example. We are in the occupied Palestinian territories, and it is we have cooperated in a project for the restoration and developing the site of the Nabi Musa heritage site. It is also a UNESCO protected heritage site. Laser scanner survey and photogrammetric model were useful to integrate the historical, typological, and morphological documentation, with the aim of putting into place operation of rehabilitation and promotion of the sea. In the video, you can see the use of our 3D modeling of the place for realizing, on one hand, a sort of cartoon that was showed in a part of this place that was dedicated to the exhibition of the history of the place. And here we can have a video about the evolution of the system, starting from the original part and the original little Moscow that became a sort of caravanserai because we are in the very close to the Dead Sea and to the desert, so it's very important the opportunity to recover in the history, to recover the merchant and the visitor. So now it's this is the situation. This is the visualization of the result of the project, and this is important also for the communication of the aim of the project, as because it's not so easy to reach this place, so we have the opportunity to visit through a virtual tour the museum and the place that is now very dedicated and open to the tourism. So thank you very much. I have shown this short presentation, and if somebody of you can have some questions, I can give in the chat a link to YouTube where you can see a more complete video. It's 50 minutes of video about our experience. So thank you very much again for the invitation.
Thank you very much, Stefano, for such a wonderful presentation, video presentation. That was really interesting. Thank you very much. So can you please stop sharing the screen so we can go?
Yes, I'll try to stop sharing.
Thank you very much. So I can see questions and answers in our chat box. Renee and Peter having a nice chat there. So if you have any questions to Professor Bertolci, so you're welcome to ask them in chat box. And we continue our conference and go to the next speaker, Professor, UNESCO International Council on Monuments and Sites from Greece, Alkiviadis Prepis. Professor Prepis, hi. It's nice to see you this year again. Hi.
Hello. How I try to share the screen.
Okay.
But I don't see my screen.
That's a challenge.
Just a moment.
Mm-hmm. Great. Okay, you did it.
Is it okay now?
Yeah, fantastic.
Okay. Do you hear me well? Okay.
Yeah, it's all fine.
Okay, thank you very much. First of all, my great thanks to organizing committee and personally to Director of Kazan State University of Architecture and Engineering, Professor Nizamov, for their kind invitation to participate in this very interesting Congress. So, my presentation deals with historical monuments in the Balkans after 1990, issues of protection, management, and cultural identity. The recent wars in the Balkans and the fate of the monuments. The policy of eliminating the presence of the other and of erasing the elements of his historical memory was repeated with particular cruelty during the recent nationalistic wars that followed the collapse of the former Yugoslavia, 1991-1999, and the creation of new national states, or more precisely, the resurrection of the national states of First World War in the Balkans. Then secular and religious monuments of heterodox, Muslim, or homodox, Orthodox or Catholic, although until a shortly compatriot, became the subject of targeted distraction attacks to the extent that they constitute symbols of a different ethnic identity. The historic city of Dubrovnik, Ragusa in Croatia, was inscribed on World Heritage List since 1979. From 1st October 91, when Croatia announced its independence, and for 7 months, Dubrovnik was besieged by the National Navy of former Yugoslavia. The harder bombing took place on June 12, 91, when 19 people were killed and 60 wounded and caused serious damage to many of the historic buildings of the city. In total, of 824 buildings of the town, 68% of them were hit by missiles, while 6 could be destroyed by fire. You see here the last photo of this photographer. After a minute, he was killed. And this is his last photo on photo camera. Now, in this very place, 1 million of visitors stream in Dubrovnik each year. The besieged city is trying to work out ways to manage people's love. The primary problem is crises, which arrive with thousands of visitors at once, clogging the streets and making it difficult to even enter the old town. Currently, the state limit is 8,000 visitors, after which the gates are closed. In Bosnia and Herzegovina, the identity of the Mostar city related mainly to its status as intercultural crossroads and meeting point of different nationalities. The famous Mostar Bridge from 1566 was a work of Mimar Hayreddin, a pupil of the famous Koca Mimar Sinan, the greatest architect in Ottoman Empire. Mostar Bridge was bombed as a political act during the civil war in ex-Yugoslavia in 1993. After the destruction, the original parts that remained in situ were kept, but the arch of the bridge was entirely rebuilt new on the original site in 2004 with the support of UNESCO, Aga Khan Trust for Culture, and World Monuments Fund. More than $15 million were spent. Although the site has certainly lost part of its authenticity, the World Heritage Committee inscribed the site on the World Heritage List in 2004, emphasizing its significance as a symbol of reconciliation, international cooperation, and of the coexistence of diverse cultural, ethnic, and religious communities. UNESCO has pointed out that the intangible component is as important as the physical. The previous is certainly the main issue concerning the outstanding universal value of this site, already having been accepted by the local people as Renaissance of the monument. The case of the Bridge of Mostar gave rise to other communities to express their will for full reconstruction of religious monuments, communities' unity symbols. The colorful decorated Al-Ajah Mosque in Foça, erected in 1551 by Ramadan Aga, also a student of Koca Sinan. And on the other side, St. Trinity, this is Al-Ajah Mosque, which was razed to the ground, as you see here, during the war events. And now here you see the reconstruction the day of the opening. And St. Trinity Orthodox Cathedral in Mostar, a work of the Slav Macedonian architect Andrea Damianov from 1873, it was also leveled to the ground. And now both monuments are full under reconstruction process by the local religious communities, as you see here. What makes a completely reconstructed building an asset of architectural heritage? Most certainly, it is an immaterial component. The cultural significance
Professor Prepis, could you please switch on your microphone? You switched it off. No? No. We cannot hear you still, no. Okay. Doesn't work. Maybe you may use microphone or headphones, other headphones. Can you say something?
Hello, do you hear me now?
Great.
Okay. Excuse me.
That's okay.
Okay. During the recent wars in the Western Balkans, actions of intentional destruction of the cultural heritage took place. Mosques, churches, and hundreds of historic buildings were burned down or blown up. Religious and cultural symbols were eliminated. Graveyards excavated. In 2004, in an outbreak of new nationalistic vandalism, Christian monasteries, churches, cemeteries, religious and historical monuments suffered severe disasters. The Joint Committee of UNESCO and Council of Europe group of experts, to whom I participated, recorded a total of 48 Christian, 14 Islamic, and 13 monuments of traditional architecture more or less destroyed. The monasteries of the Serbian Patriarchate of Spets of Gračanica and Dečani, as well as the Cathedral of Our Lady Ljeviška in Prizren, are the four most important monuments of medieval Serbia, representing the mature phase of the Paleologian Renaissance in architecture and wall paintings in Kosovo. You see here the Devic Monastery.
I'm sorry, Professor Prepis. Unfortunately, we cannot see the presentation. Is that okay?
Yes.
So no presentation. No sharing screen presentation. Okay, so any questions?
Do you see this now?
Yeah, now, yes. Now it's okay.
Shall I continue?
Yeah. Yes, please.
Okay, so you see here during the war, the monasteries are under the protection still now of KFOR. And the post-war peace policy imposed by the United Nations considered the restoration or reconstruction of religious monuments as a condition sine qua non for the consolidation and peaceful coexistence of the region. Many monuments have been repaired, but as you see, these monuments are under control till now. You have to pass 4 checkpoints in order to reach Pets Patriarchate, for example, till now. Vysoki Decani is under the protection of the Italian troops till now. Of course, many monuments have been restored. As you see here, the Sinan Pasha Mosque in prison before and after the restoration. Or traditional houses like the Koulas in Kosovo to the border with Albania under the Acts of Cultural Heritage Without Borders, an NGO. You see here in Jakova, the famous mosque, Hadou Mosque, after restoration. Or the bazaar in Jakova during the war and after the restoration. You see here in the biggest tobacco factory in Serbia, in Kragujevac, which was bombed by the NATO as a war place, curiously. And not only this, also the Memorial Park, which was an ex-concentration camp by Nazis, and the monument or the Museum of Genocide itself, they were also bombed as war sites. A phenomenon with a growing tendency in the Balkans in recent years is the rehabilitation and drastic renovation of historic churches and monastic complexes, with exceptional historical significance, but in particular, the Serbian Orthodox Church seeks to restore or build all monasteries supporting cultural, religious, and ethnic identities, requests which are even more pronounced after the recent relocation of Christian communities in Kosovo, when historic monasteries have been found isolated in a different religious background. This is, for example, Stari Ras and Sopocani. You see here World Heritage Site, absolutely isolated in Novi Pazar, near Kosovo. Or here there are plans for full restoration or reconstruction, if you like, of the monastery, of which only the Catholicon, the main church, has been remained. Or Đurđevi Stupovi in the same area. You see the condition after Second World War. There was a partial restoration or reconstruction, if you like, to protect the wall paintings, but now there are plans for full restoration or reconstruction, which have stopped by UNESCO, of course. We have similar interventions, new additions in Ravanica Monastery, the famous place for Prince Lazar Foundation. In Bulgaria, we have similar good and bad examples, as you see here, the restoration of Santa Paraskeva in a very touristic place, the ancient city of Nesebar, under a very strong touristic pressure. Or the full, the partial reconstruction of monuments with not very sound evidence. As you see here, this St. Dimitrios Church in Veliko Tyrnovo, of the original of which only the eastern part was remained, but on unknown evidence it was totally reconstructed. Or the again in Veliko Tyrnovo, the cathedral, which was restored on the basis of this sketch on a manuscript, a medieval manuscript. Of course, we have good examples like these traditional houses in Philippoupolis. Philippoupolis again is a marvelous city. Was a cultural capital city in 2019 with the remains of the ancient Roman hippodrome and the totally restored Jumaya Mosque here. Unfortunately, the tobacco city nearby, full of these crisis tobacco methods, was intentionally put in fire to build new hotels, and it was the locals which reacted drastically to stop this evidence. We have good examples, for example, in North Macedonia. You see here Ottoman buildings, this House of Army in Bitola, or the Ishaq Mosque. Here is the Russian consul building, and here non-appropriate, as you see, new construction. In North Macedonia, we have sometimes, the interpretations which lead to a rewriting of the history. Venice Charter, even in 1964, says the valid contributions of all periods to the building of a monument must be respected, since unity of style is not the aim of a restoration. When a building includes the superimposed work of different periods, the revealing of the underlying state can only be justified in exceptional circumstances, and when what is removed is of little interest, and the material which is brought to light is of great historical, archaeological, or aesthetic value, and its state of preservation good enough to justify the action. So the recognition of the cultural diversity means respecting the contributions of all historical periods, of every culture and every religion, including those who are minority in a country. However, there have been interventions for the interpretation, as you like, and the rehabilitation of or rebuilding of historic monuments, which altered substantially the monument's history. Here you see in Ohrid, it was a very, very big city on Via Egnatia. You see remains here of Via Egnatia. And it has a double nomination as natural and cultural heritage. Old views of the city, as it used to be in the beginning of 20th century. Two exceptional monuments, one of which I was involved with the architectural restoration, is St. Clement Church in Ohrid, with exceptional wall paintings, which were restored by a group of Italian colleagues. You see the condition as it used to be and as it now. Of course, we have very good examples of restoring traditional architectural buildings, but also bad examples in the core of the historical city. New buildings and no control of the parking places, as you see, new inadequate modern material use. Okay, we have very good cultural events, but you see the uncontrolled situation and new inadequate interventions on the ancient theater. The citadel, which dominates, you see how it used to be in the beginning of 20th century and how it looks now after the very strong interventions. One cannot recognize what is the old and what is the new on this building. St. Sophia Cathedral is one of the most, one of the biggest monuments of the Slavs in the Balkans. It was the first monument after Second World War that had an intervention by UNESCO in order to support the building and to save the interior valuable wall paintings. Now you see what's happening on the other side of the road. New intervention, unacceptable. Inside there used to be the altar canopy, which was converted to Islamic minbar. Actually, it is the ambon of the Byzantine building was used by the Muslim people. Now it has been taken away, and a new iconostasis made of absolutely iconic, fantastic has been put there. The most severe and disaster intervention is this. There used to be a monument in the 9th century, the so-called first university of the Slavs in the Balkans, by Saint Clement. That was a Trico church, and after that has accepted some additions. In this very place, Ottomans, they destroyed it, and in this very place they have erected Imaret Mosque, which was till 2000 in this stage, as you see on the picture. The local authorities, academicians, decided to destroy it, and in its place to build up an absolutely imaginary St. Clement Church in Ohrid, taking, how to say, examples of existing monuments all around the Balkan area. It's an absolutely imaginary monument. So a foreign tourist cannot understand what is original and what is authentic and what is not authentic. And in the same archaeological site, it is erected the great volumes of theological university in this Plaosnik place. We have very good examples from Albania, as you see these monumental houses in Gyrokaster and Berat, which are on World Heritage List. Here we have heterodox Muslim minority, and you see their shrines, which are very well kept, Teke Helveti, for example, in Berat, as well as Christian community with this exceptional Mother of God Church, which is a museum of the painter Onufrios, post-Byzantine painter. In Turkey, we have very interesting interventions. They start up with the restoration of Edirne Palace, which was burned during the Russian-Turkish wars. And of course, we have the Kulie of Bayezid II, which was awarded by European Union as an exceptional restoration monument. It was actually a medicine university on those times in the 16th century, training patients with the help of music and water, the sound of water, among others. And of course, the Selimiye Mosque, which is the opus of Mimar Sinan, the masterpiece, which is exceptionally restored and maintained, together with the surrounding area of the bazaar. We have the restoration of this caravanserai from the beginning of 17th century, a common action between Turkey and Bulgaria for cultural events. And to my opinion, it was visited by Le Corbusier during his visit in Orient. And I think he has inspired by this interior for his famous Rothschild Chapel. But this is another story. The minorities, either does not exist, their shrines have been maintained, like the restored Catholic Church and the Bulgarian Church. But unfortunately, the exceptional is the synagogue, as you see here, an exceptional building which was in very bad condition. You see here, you can compare the photos, and now it is exceptionally restored and visited by Hebrew people from all over the world. Unfortunately, nothing is remained from the Greek patriarchal church there. Only some ruins. That is to be said. The core of the old city is of high value, but it needs a lot of work to be done with these very interesting good examples of houses, among which are Greek buildings of rich people, of rich traders, or administration buildings of the Greeks. The most interesting archaeological site now in the Balkans, and not only, is the Yenikape archaeological site. During the excavations for the new metro under Bosporus, they found the old Byzantine harbor and stopped the works. They changed the plans, and they found 35 Byzantine ships full of objects inside, and that's a good bravo to our colleagues, which decided to make an exceptional archaeological site there. An international competition. The first prize was given to eminent American architect Peter Eisenman. You see here the maquette of the future building. It's an international effort to all these findings to be maintained and properly preserved. In Athens, we have many Muslim monuments, as you see here, the baths, which have been maintained, not only all over Greece. In Thessaloniki, for example, public buildings and religious buildings maintained, buildings of rich merchants, Turkish people, or Italian traders, and the exceptional Imaret in Kavala. It was a building made by Mehmet Ali from Egypt. He was born in Kavala, and it was a gift to his birthplace. Now it belongs. It has been transformed into a very luxe hotel, and other religious monuments from all over Greece, as you see. There is another policy now for the foreign monuments, as you see. An exceptional case is the Didymotchon in Greece, one of the earliest religious monuments in the Balkans. Unfortunately, it had a very luxurious ceiling, but unfortunately, during the restoration, it was burnt, and all the ceiling has gone forever. Unfortunately, it happens. Now, I would like to finish my presentation. I would like to thank you for your patience and touch the subject of the inability of the restoration, or if you like, the limits of the restoration. You see here the Sarajevo, a city which has been martyred during the war events. Some aspects of the buildings before and after the war, after the recent reconstruction of the city. And you see the the memorial event in 2012 in the memory of the 11,541 victims of this siege of the city. The same number of empty red places in the main street of the city. I will read the words of a colleague of ours, Andrew Hersher, professor of architecture in Michigan University. However, the most profound contradiction of the restoration is not political, but conceptual, built within the idea of the restoration itself. The underlying dilemma of restoration is not implemented with insufficiency, or that is structured with political ideology, but that when totally realized, disputes the irrevocability of the disaster, the inability of restoring all that eliminated by destruction, but also the necessity of rejection and the mooring for the destruction, rather than to explain, defend, or make overcoming. This idea is eloquently expressed by the Croat writer Dubranka Ugresic in her book, The Tale of the Bomb and the Book. The essay deals with the destruction of the National Library in Sarajevo during the siege of the city in 1992, a building which housed 1.5 million publications, including 155,000 rare books and manuscripts, all of which were disappeared. Now the building is completely restored, and was ceremoniously reopened on the 9th of May 2014 on Europe Day and they victor over fascism. Ugresic notes, an object that has been destroyed cannot be replaced. It disappears forever. The destruction is never purely physical. It has many facets, multiple meanings, but is always final. We will build new libraries and we will publish new books, say the optimists, accustomed to a normal rate of destruction and reconstruction. But the idea of reconstruction contains inherently the future disaster. Architecture itself is never guilty or innocent, is never wrong or right, never political, but politicized. Therefore, restoring heterodox or foreign monuments should be extolled, whilst the destruction of buildings expressed in different cultural entities and different communities to be condemned. And we should always bear in mind both the fragility of the restoration and the irrevocability of the destruction. Thank you very much for your patience.
Thank you very much, Professor Prepis. That was nice. And we have a question, a quick question from Renee. Actually, this question is addressed to you and Stefano. How can politics and conservation and preservation work together? Is it ever possible to restore cultural heritage through reconstruction of architecture? What do you think? The question is in chat box.
Is it for me?
For you and Stefano, but we would like you to answer that question first.
I think it is, I have already answered during my presentation.
Okay, so maybe.
Yes, you did answer it and you explained it really clearly. But my question is really, how important is architecture for cultural heritage? Like, what are the other factors, and how can architects and architectural conservationists and politicians work together?
Okay, we can, of course, reconstruct, if you like, or restore buildings, but we cannot give them back the interior atmosphere. For example, all these buildings which have been restored in Kosovo are empty boxes.
Yeah.
Unfortunately, you can, for a simple explanation, all the interior decoration, I mean icons, valuable icons, iconostasis, wood carves have lost forever, have been lost. So this monument will never be the same in the future, never. And it has to do with local customs, feelings of people, what connected them with the old history of the building. So to my opinion, this is a new building.
Mm-hmm, mm-hmm.
You understand?
Yeah, completely. Thank you. Yeah.
And there are many examples of this, even for World Heritage monuments. I will explain to you. Sometimes, in most of cases, a building carries its history on his shoulders. Mm-hmm. This history has altered its appearance during the centuries. So what we receive now is the result of all these changes. Actually, no monument is original, never. We have the result of its history during the centuries. And the big question is, what character we as restorers will offer to people, will offer to future generations in order to understand the history, the real history of the monument? That's a very big question.
Thank you.
You're welcome.
It's a very interesting debate. It's the most important debate in the restoration in Europe. We have several experiences in Italy, but I want to underline only few examples. I agree with the professor because a monument, if you destroy a monument, you will destroy the memory and so on. And also the other aspect is that the monuments that we have also alive, for example, cathedral and so on, they are now in use. So they are the results of several transformations that maybe conserve the original way or not. But this is not important. Only in my think only archaeology conserves the original. But now we use the monument. So we have these different function. The function is the discrimination for the two kind of work. But for example, in Florence, we have had in the Second World War, we have had the destruction of the bridges of the town, except the Ponte Vecchio. Ponte Vecchio wasn't destroyed. And what happened? What happened that after the war, we have several competition for the reconstruction of the bridges. And all the bridges are new, but at the exception of one of the bridge. That was Ponte Santa Trinita, because this bridge was projected by Michelangelo, and a consulting of the population want to rebuild its the bridge like it was, and it was reconstructed with the stone that they found in the bottom of the river. So this is, but so it's very difficult to have a very hard position, because in certain case you can remain also the question of the tower bell of San Marco in Venice that followed down. Oh. Is new now, but can you imagine San Marco Square without the bell towers? Maybe now we have some exception in this, but it's a very, now we are happy that we have some San Marco bell tower. Also in Florence, everybody is happy to have this review of the Santa Trinita Bridge. But we have here new elements and only one rebuilt. So this is, I think it's a very important, the moderation of reconstruction. I think it's the better thing that we have to do. And another thing that we have to take in consideration, not only policy, but the participation of the population, because only the population knows very well what is the true background of his history, and if the population can agree with a new complex, with the substitution of with a new architecture. I don't agree with some kind of the situation of the architect star systems. For example, Professor Pepys has shown us the result of a competition of these beautiful archaeological areas. I think that nobody from United States can project something for an archaeological area. No, it's impossible. So thank you, is my opinion.
Thank you very much, dear professors. I think you can talk forever and discuss these questions forever. Yeah. I'm very sorry for interrupting you, but sorry. We have time limit. Thank you very much. The following conversation, you may do that in chat.
or you may just exchange your telephone numbers and have a conference there. Thank you very much. That was very interesting. And now we would like to give the floor to our next speaker from, oh, I'm sorry, I forgot. If there are any questions, any other questions? Does anybody have questions? No, nobody. Okay, so the next speaker is from half China, half Italy, professor, researcher Tiziana Cataneo, if I pronounce that right.
Perfect. Hello, everyone. Thank you so
Ciao,
much.
Tiziano.
Ciao, Stefano. Nice to meet you here. I miss you, Stefano.
Okay,
Okay.
L'opportunità.
Okay.
Sorry for these greetings.
That's all fine. That's all okay. Thank you. So, Professor, ready?
Yes, I'm ready. Are you going to share my screen?
Yeah.
Okay.
Great.
Can you hear me and can you see my screen now?
Perfectly well.
Yes, that's great. Thank you so much. First of all, I would like to thank the university, the State University of Kazan, and see here many old friends and also hopefully new friends. So another thing, I'm very glad to participate in this conference, this event, a multidisciplinary conference with many scholars from science and technology fields. But I have to say I'm designer and architect. I come from the arts and humanity field. So I would like to attempt to engage you with my presentation today. So as you, has been presented before, I'm actually holding a sort of double affiliation with the University of Pavia and Tonge University, where I spent the last 4 years before collaborating for more than 15 years with the Tonge University. And that's why today we're going to present a research project, a research by design project that I had the pleasure and the honor to participate in that contest in Shanghai. So here is the outline of my presentation. I will go fast as possible because it is late. So first of all, what I would like to share with you is the starting point when I arrived in 2015 in China was try to create a new understanding of the community where the Tonge University campus is located in order to try to improve the quality of life and engagement of the people. So we started with a very basic observation of the understanding first, of course, and observation of the context. And then we start to, from a very broad view, which is, for example, the actual situation that all of us know very well about the climate change, that the impact also is not only a issue that touch some other places, but where happening in China or where happening in the Arctic is also affecting our life and our environment, and also in our living condition in the urban areas. So those very broad, but also and very and very simple observation. This is one of the day that happen often in Shanghai, the severe pollution that we can find there. Starting, as I'm saying, this observation that actually they are involved all the worldwide. It's not only specific in one location, the other. We arrive to try to define how we can, due to the complexity of our goal, how we can use design to improve the quality of urban life and specifically the communities in very dense urban cities such as is Shanghai, for example. And we decided to started to study this nature-based solution, which is actually a kind of a new research line that born in Europe, but actually now Chinese government embrace together with New Zealand a new guidelines for adapting nature-based solution in urban areas. So this is a long history, the timeline of this terminology, of the concept of the nature-based solution. I will go very fast, and then, of course, if some of you have more curiosity, can, of course, ask me by email or in the chat. So the context of the European context, the nature-based solution actually are devoted to renaturing cities and then focused on the new and innovative solution that can bring sustainability and regenerate the environment in a broad, in a big scales, but also in details, and then using, of course, the nature as a base to create our solution. So we have different, of course, possibility and different scale, and we are here in enhancing the sustainable urbanization with different scales and approaches that we can apply for regenerate and renaturing our city. Starting from the point that, of course, nature and greenery is already well known and proved by scientists that is very important for the quality of the life, for psychology and social benefit. So this project is also developed within another project that is in University of Pavia, led by Professor Roberto Dell'Otto, which is an Horizon project called Re-Energetic. So if you want to get involved or get informed, you can visit our website or send us an email from this address. And another thing that we studied before to start to apply some potential solution was the urban greening tools available worldwide. We have seen that there are many greening tools to apply in an urban area. But for example, we have the Biotop Area Factor in Berlin that is very efficient and very interesting greening tools, where they calculate actually the relationship between green area and building area. And then we have in Malmo, for example, with a different way to calculate the square meters compared to the urbanized area, or in Seattle, or in Poland. Also in Shanghai, the new Master Plan 2035 decide to improve the green and areas and the vegetation within the city. One of the most advanced, I think, greening tool is the one in Singapore, where they define a total area that should be equal to the building area. So there are many tools that can be useful for designer. However, what we have seen, every of these greening tool, they are not directly connected with citizens and with the needs of inhabitants, and mainly they don't involve the citizens in the process of regeneration of their urban area where they live. So what we did in Shanghai, is starting from the fact that actually the concept of natural-based solution itself is nothing new, but at least recognize that there is a problem and needs to be solved as fast as possible. What we tried to do was an application in using a mixed complementary approach between the top-down situation that we have in China and the bottom-up approach for that we try to teach and research in the university. So thanks to the dean and several other colleagues in Tongji University in the College of Design Innovation, was established this platform that is called Neighborhood of Innovation, Creativity and Entrepreneurship Toward 2035. Is NICE 2035. That is actually a cooperation between the local government of the shipping community. When we talk in China, and shipping of community means 100,000 inhabitants. So is actually a sort of small town in Italy. So the promoter of this initiative was the college, the university, and the local government, together with other association, citizen associations. The scheme of under which we apply our research and our design also was in try to create a sort of hub where university, citizens, students, researcher, and local government and several stakeholders can enter and collaborate and have their output. So a sort of circle between the community, the talent available in the because we have the space of the university that attract hundreds of young people and also many scholars and many other people that can invest in this new hub, and then entering more in detail of what we have done is this is Shanghai. So we have the Yangpu district, which is this is a district of 1 million inhabitants, considering that Shanghai has 27 million inhabitants. So this is a little pink dot is the shipping community, which is include 100,000 inhabitants more or less. So the area of the shipping community is 22.75 square kilometers, have 23 neighbors, and was founded in during the 50s as a worker village. And after the transformation from and the moving of the industry from outside in another area of the city, and the establishment of the campus of the universities such as Tongji University or Fudan University, which are two of the most important universities in China and for sure in Shanghai, many leftover places remain there. Here you can see a demography of the shipping community, and here you can see some picture of from the skyscrapers surrounding the area, how it looks like in nowadays. So we have mixed function that is not so common to find in area in China, but also we have a lot of space like this that we have bigger functions such as university and others new compound for residential area, but also we have a very active and vivid community in this area, composed by most of all of migrants, Chinese migrants, and other people that looking better life in the big cities. So as I said before, we set up a sort of framework of work in our community, in our college, that together with the students, we create a call for proposal for others, artists, designers, and other stakeholders. And we called this project Open Your Space, and we was initiated in the 2015. So since then, the local government support us in creating workshop with the people, with the inhabitants, and created debate between students and citizens of the community, expressing their wish, how they would like to see the community in the future. So also with the elders, and also many activities with children. It was a very part of our approach, because as you can understand, it's not easy to get involved with many people with different age, with different behavior. So we started to create in a leftover space a small exhibition where we exhibit all the material collected during those workshops with the citizens and inhabitants of the population. We create public debates. And that is actually, as you can understand, is not so common to find in China, this kind of activities, or this kind of path of design and regeneration, with inclusion and a lot of participation by different stakeholders and different people living in that areas. We start to create a kind of a sort of models how regenerate with nature their roads and these leftover spaces, those abandoned area within the city. So by creating some small sketches, and then again involving different typology of artists and designers, urban planner and architects, we create several 50 micro intervention in the community. Beside that, of course, we mapped also all the vegetation and all the existing potential area for developing our project, and we find you can see this small orange dot, different area where we can apply and where we can try to encourage people to take care of their space, along with the support of the local government, of course. So we started with a small project. This is a leftover space of 2.5 meters wide and 80 meters long. And because of the request from the citizen to have a playground for children, we created this activities, this small installation for the children, along with some renaturalization of those small alley, including, of course, activities, direct activities with schools, not involving only students from the university, but also from the schools, from middle schools and high schools. So as you can see, we create some event after the construction of this small pocket garden, and with music and with activity of planting and other activities with all the cities and other project was a building that is belong the let's say the sub-district office of the shipping community, and what we have designed again through the same methodology is a regeneration of the building itself, and then the creation of again one playground, and we invited students and artists to cooperate to create these fantastic murales on the building. And then, of course, thanks to the School of Design that include also media and dancing and different possible fields of study, such as, for example, dancing. We invite the student to create performances in that area, and including involve the student to create and children of the neighborhoods to create and to paint the murals. So this was the second project. And the third project was the regeneration of a sort of garbage storage. So no, actually, this is very dirty places in real terms, because all the garbage of the community was collected there. So the local government asked us how to regenerate, how to reuse it, and at the beginning was looks like impossible, but in the end, after different and several treatment and cleaning, we decide to establish there a new lab, a sort of open lab for the community. Of course, there is also some activities of the PhD students or other researcher of the college. So this place is that was very everybody in the community wanted to avoid to pass through this area. Now became a kind of information point for all the citizens that are living in this community. And we created then many other activities thanks to the collaboration of students, PhDs, and other artists in residence that we have been able to invite during the last 5 years. And again, in the citizens, and when they have international guests, such as here, for example, we had 25 students from Mexico to visit Tong University. The citizens were very happy to host them and create a dinner outside of these places that was an abandonment and leftover places of the community. Other project with did a little bit more big scale are the community gardens. Again, here designers such as for example, in this case, our main collaborator was a very interesting guy called Liu Yelai. Is a Chinese professor in Tong University who is a landscape designer. We combine his knowledge about planting, about vegetation, and so on, and our approach to involve people of the community in creating their own garden, or orchard, their own public space where to improve the quality of their life. So we plant 3 small community garden in again leftover places, abandoned area in the surrounding the community. And okay, we apply several methodology, and we have also different of course results from those experience, because sometimes it's not easy to involve the peoples. Anyway, as a conclusion, since the 2015 until 2018, and then the outbreak of the virus actually stopped and make slowly this process of renovation of the community, that year by year, thanks to those events, it was possible to improve the quality of several spaces, as you have seen before. We achieve at least to have 2 things. One is an online platform where all the citizens are connected and want to create and discuss what's next, what happened next, what we can organize for the next year event, or what we can ask for the local government to regenerate for our children and so on. So they can discuss online, even though they are controlled, of course, as we know, from the Chinese system. And then, of course, thanks to all our projects that you can see here in this red dot, we create also an offline community. I mean, the community that surrounding the Tongi campus, the Tongi DNI campus, which is this one pink, create a meaningful relationship between a mixed population, mixed inhabitants that are living there, that include elder students, migrants, workers, and also international students and international scholars. So the Open Space project, I think, is something very interesting. Also, in somehow for Shanghai and China environment, and a kind of, let me say, revolutionary approach. And what we learned that we have to think big and at a small scale. So it doesn't matter after the so huge and strong development, urbanization, and economic development that had China in the last 20, 30 years. So we have to restart to think in another way, I think. And this initiative, I guess, starting from the nature of the places and using the nature for regenerate our cities, our environment, can achieve, I think, good results. Thank you so much. I apologize to talk so fast, but I have to jump in a few minutes in a classroom because I have class here in Pavia now. I would like to thank all of you. Of course, I have still time to answer if there are any questions. Thank you so much again.
Thank you very much for the interesting topic, for the interesting report. We wish you good luck with your students and your class. Thank you very much. And if we have any questions, we will send it like your direct message to your email, or maybe a short message to your telephone. Thank you very much.
Thank you.
Thank you. So, and the last but not the least, again, my favorite phrase for today, Professor UNESCO Chair in Urban and Regional Planning for Local Sustainable Development, Coordinator of the Mediterranean UNESCO Chair Network, President of International Laboratory of Architecture and Urban Design from Italy, Paolo Ciccarelli. Do you hear us? Paolo? Paolo? Лилия Дусна, is Paolo here?
Сейчас смотрю.
Что-то
нет. Он здесь.
Paolo, can you hear us? Paolo? Anything?
Paolo, può parlare? Не знаю,
Paolo?
что происходит.
Maybe we should try other languages. Puede hablar, Paolo, por favor.
Tiziano, forse puoi aiutarci con Paolo? Не знаю, Tiziano вышел, нет?
He's calling.
I'm trying to call in Livia. Eccolo.
Ecco.
Okay.
Okay, sorry to
That's okay.
have made some troubles. Anyway, I thank you very much for this invitation. I'll be very short because we are late, but I think that is just the beginning of a relationship in between the State University of Kazan and the small institution and organization I am in this moment president, and in an institution in which Tiziano Cattaneo, by the way, is involved too, and that has a long history and has also a very interesting curriculum. This institution is called the International Laboratory of Architecture and Urban Design, ILAUD. It was founded in 1976 by Giancarlo De Carlo, that was an Italian architect with a very wide and important international experience, in order to renovate and continuously try to change and improve the education in the field of architecture and urban planning. The school was in some way not organized according to the normal principle of the education system all over the world, but was more a sort of collection of different experiments of teaching in different moments of the year, in different places of the world, putting together friends that wanted to experiment new ways of making research involving young people in the most important issues that had to be faced, and also introduce more direct form of training in the field of architecture and urban design, with a very strong involvement of local communities in that. The school and so the principle that in some way had been developed by a group of European architects that in the late 60s and early 70s, a group that had split from the SIAM organization founded by Le Corbusier, and had set a group, a famous group called Team 10, to which that generation belonged and produced many important things around the world. Originally, this group that involved a very wide number of universities around the world, the most important one at that moment, but was basically based on relationship in between Europe and the US or North America. The history of ILAUD went on for many years. Several thousands of youth had the opportunity to pass through these experiments and these workshops that were held in different parts of the world, but basically and mostly in Italy, in very important Italian cities like Venice, Siena, Urbino, and so on. I was involved at that time. I was much younger in this experiment. De Carlo was my professor, my reference, and then after many years, I became responsible for this school, and we started at the beginning of the year 2000 a different approach to the problem, since the world was no more confined to the western part and the two continents that were the base of the European and North American culture, and Latin American culture, but was much wider and was no more Europe and the America in some way the reference to the architectural culture and the most important problems that were to be discussed and solved. And so ELAUD continued to work along these lines in a different way, in some way according to new times, but at a much larger scale. And we became to work in different parts of the world. So we worked in China, in India, in Japan, in Africa, in Palestine, and in Latin America, in Brazil, Argentina, and in different cities, and joining forces with a very wide number of different schools in small groups of students and training people in a different way. So basically, the idea was to have younger people approaching very important issues in a sort of more fresh, open-minded way than in the institution where they had been trained, the schools, even if the schools were very important, in a sort of non-orthodox approach to many of these problems, and in very strong connection with the local communities and the local culture, and very conscious about the fact that the variety of cultures and the contradictions that many times dispose to the elaboration of new methodologies and new ideologies and new cultural lines for architecture and urban design had to take care of the fact that the cultural values of different parts of the world had to be taken as a major asset and used as much as possible, even in a dialectic way, to enrich the debate and try to overcome the sort of fragmentation and over-specialization, many times based on a sort of technical and also rather marginal aspect of culture that had become very diffused among the schools of architecture and planning. We went on for several years, and basically we decided to have a further step 2 years ago, 1 year just before the pandemic, because it was the first centenary of the birth of De Carlo, and we wanted to celebrate it in some way, redefining the role of ELAUD, reorganizing the association, and also defining new goals and new ways of approaching the problems. At that moment, we put at the center of our debate, and we had a number of international seminars discussing about that, the problem of the environmental transition and the digital transition. We had a very, very bold program for 2020, and we had a number of workshops in India, in China, and in Brazil. Everything was stopped because of the pandemics, and we have to rework it once again, our program. We have been very active, even working on remote and trying to develop as much as possible new lines of work for the future in order to keep all the friends around the world in contact for new programs having new objectives. Now we are in some way working along 3 lines of work. We hope that as much as possible will restore again a sort of work on presence in specific sites where we can work directly with the local communities, but At the same time, we have worked out programs that in some way are, or even if without the possibility to work directly together, are joining forces and putting together a very wide number of institutions along important programs in different parts of the world. The first program on which we are working now, and in which we are very happy to have the Kazan State University participating in, is a World Forum that we will have next September. It will take formally place in Milano, because in Milano in September there will be an very important international event that is called Youth for Climate, and is an international event connected with COP26, that is the intergovernmental program connected with the agreements of Paris that have been relaunched recently by the governments of the US, Russia, China, and obviously Europe. And this event that's we have presented to the organizer of this international meeting will present the work that 15 schools of architecture of all over the world, of 5 continents, are doing on issues connected with climate in cooperation with local communities. So in some way, work done by young people in the schools in connection with local communities. And so even if it's done in the university, it's not an academic work, but is an experience of education that is giving new perspective of training to people that in the next future will be in charge of facing very serious problem of environment and climate change, and also the very serious social and economic crisis that have been produced by the pandemics, and that will create for everybody in the world very, very challenging problems, and the need of very bold new policies, and to have them presenting what they are doing and trying to build up a larger network of institution and group of young people working along the same lines, experiencing different cases and trying to find common lines of research and education. We'll have also a couple of roundtables. So we hope, obviously, to have friends and colleagues from the Kazan State University participating in it. We are defining the program, and things are moving ahead. I think that this is important, this first sort of meeting, general meeting, because is the first step toward this idea that is in some ways the base of the philosophy of Ilaud, that there is a great need in this moment of rediscussing basic values on which the education of architects and planners is based. There's been too much specialization, too much fragmentation. The students must rediscover a number of key issues and key values, even through the exchange of ideas around the world, because the issues we have to face in the future are extremely difficult, and because some of the policies that will be launched or are in some way online, like the next generation programs launched by the European Union, and so with very, very large investment for totally new kind of solution, require a different way of approaching the problems, a different way of trying to solve them, and also a different switch in mentality in facing a number of issues that many times in recent years have been reduced to a sort of mechanical kind of answers, sort of like early generation computers giving sort of binomial kind of answers and not so sophisticated. A second area of work, and that is in some way connected with the first one, is instead a program based on two cases, two experimental cases. One is in Milano, the other one will start in another city in Italy, that is Genoa. And these cases are areas of, two areas of these cities that are industrial and sort of modern cities, with having a number of issues common to many, many other places in the world, working with the local communities, very strongly connected with them, in a process of co-design and co-answer to major issues that these communities are facing because of, and will face because of climate change, because of the economic and social crisis produced by the pandemics, and because of the need of a total reconversion and reinvention also of answers to urban development. And we are already starting to work in the case of Milano. We'll have a number of workshops with the local community on some of these key issues. Just to give you an example, one of the topics is how can be organized in some way in urban structures that are traditional ones, having housing typologies that are were designed according to a certain kind of family life and organization of the life in an apartment, in places where you can have a remote work that is totally different, requires a number of things, and that will become important in many parts of the cities, and can create again segregation and lots of other problems. So that is the difficult things we have to discuss with local people. And so these things are in some way the line of work we want to develop. A final things, an experiment we are starting now, and I think that that could be done in other places of the world. We are starting a competition in a sort of, this is a real experiment, in a small town, very live place, very, very active, of total confidence on teenagers. We have a competition asking the teenagers to give ideas, projects, and proposals, and so, and there is a good prize in money for the future of this place. So we jump to the next and we ask them to be responsible. because they have to be responsible, because in 10 years they will be the ones running the business.
The business, yeah, sure.
They have to start now to think that will be done using as much as possible the platforms that the kids like to use, Instagram or whatever.
Let's start doing that.
Yeah, and we'll see. The mayor is a young man. He's very excited on this, and we have a group of other people, the young people, that are very keen to work on that. So that is, Zoe, the mission of ULAUD is this one, to experiment a new form of education and co-education, because if we are doing this, we are educating on one side the new actors that will be in the professional activities or political or whatever, but on the other side, the community working with them on specific problems will learn a lot of things. So it will be also a way of creating capacity building in new areas for the community, and that is extremely important, especially in the period like this of resilience, in which you have to resist for a long time before having new changes that might improve the life.
Okay.
And at that time, giving you also a sort of empowerment, because the governance process will be extremely important in this period. So this is what we are doing. I hope that you'll join our work.
We will join the work. We will do that. Thank you very much, Professor Paolo. That was very fascinating speech. Thank you very much. And thank you for
Thank you for everything.
Bye-bye. Have a lovely day. Bye. Thank you very much.
Bye.
Oh, see? And now we would like to give the floor again to our Vice Rector for Research Work, Professor Vdovin, Evgeny Vdovin.
Thank you. Дорогие участники, мы заканчиваем нашу конференцию.
Dear participants, we're about to finish our conference.
Конечно, хочется поблагодарить участников за активное и продолжительное участие в нашей секции сегодняшней пленарной.
We would like to say thank you and give our special thanks to participants of our conference for such a long but very interesting conference.
Хочется выразить большую благодарность руководству вузов за внимание и поддержку нашей конференции.
Thank you very much for rectors and vice rectors presenting universities, for your support, for your participants in our conference.
Это Рашиду Низамову, Хасану Абдалла, Андрею Келлеру, Виталию Сергееву.
These people are, you should know the names of these people.
Yes.
Hasan Abdallah, Rashid Nizamov, Vitaly Sergeyev, Андрей Келлер.
Ну и, конечно, хочется отметить сегодняшних спикеров.
And we also want to tell the names of our speakers today.
Это Марк Сенджли, Роди МакИвена, Питер Лакин, Арслана Зиганшина, Николая Ватина, Стефана Берточи, Алкивиадиса Преписа, Паула Чикарелли, ну и Рене Топ тоже очень активно участвовал в нашей сегодняшней сессии.
Again, thank you very much, dear speakers. The speakers are Mark Sergey, Rodi McEwen, Peter Lakin, Arslan Ziganshin, Nikolai Vatin, Stefano Bertocci, Alcibiades Prepis, Paolo Ciccarelli, Tiziano Catania, and special thanks, René Top. Thank you very much for your participation.
Наша конференция набирает обороты.
Our conference is developing.
Вовлекаются новые вузы, партнеры, международные организации и, конечно же, ученые, аспиранты и студенты.
Okay. Every year, the second year, but every time, new universities, we collaborate with new universities, international companies and scientists during our conference.
Сегодняшние доклады были актуальнейшие темы для нашей планеты Земля.
Today we had presentation on the following very topical issues.
Такие как дорожное и промышленное строительство.
Such as road construction, road and industrial construction.
Это цифровые экологические технологии, проблемы парниковых газов.
Digital and ecological problems, gases and fumes.
Повышение энергоэффективности функционирования зданий, сооружений.
Energy efficiency, increasing in energy efficiency.
Ну и, конечно же, реставрация, сохранение архитектурного наследия и комплексного развития территорий.
Restoration, conservation of architectural heritage and territory complex development.
Желаю всем успехов.
I wish you all the best, all the luck.
Главное – здоровье.
And the most important is health. Please be healthy.
И надежду на встречу в рамках третьей конференции у нас в Казани 2022.
And hope to see you next year at the third International Conference 2022.
Thank you very much. Goodbye.
Thank you very much. Have a nice day. Thank you. Bye-bye.
Bye-bye.
Bye-bye.